Okay. So, welcome to this PhD defense by Saurav Kalita with the title Influence of Salix Variety on Climate Impact of Different Biomass Conversion Routes. I'm Björn Winnerås, and I'm professor in environmental engineering, and I'm head of the Department of Energy and Technology, and I have been appointed by the faculty to share this defense. The procedure that we will use is that Saurav will present his thesis for around 30 minutes, and then the opponent will place the thesis into a more sort of international perspective of the research area. And then it will be a discussion between the opponent and the respondent until they are sort of done. So we have no time limit. It's more sort of a chance of exploring the area a lot. After 1.5 hours, so 10:30, we will have a break for 10 minutes, just so we have a chance of refill the coffee, and also for the opponent and the respondent to have a chance of sort of gathering their thoughts a bit and then come back again in fresh discussion afterwards. When the opponent is satisfied, we will leave the word to the evaluation committee to complete if they have any more sort of complementary questions. And after that, we leave the floor open for the audience if they have any questions. And after that, then we close this session and continue with a closed post-seminar discussion regarding the grade of the thesis. And the grade of the thesis is pass or fail. So, to the involved people, we have the respondent, Saurav Kalita, that has a master in innovative sustainable energy engineering from KTH in Stockholm and Aalto University in Finland. Then we have the opponent, Professor Moritz Wagner from the Department of Applied Ecology and Sustainable Use of Resources and Life Cycle Analysis at Geisenheim University in Germany. No. And then we have the evaluation committee. We have Associate Professor Henrik Börlius from Institutionen för Sydsvensk Skogsvetenskap, SLU. And then we have also Associate Professor Maria Westerholm from Institutionen för Molekylära Vetenskaper, here at SLU also. And Professor Anna Björklund from Department of Sustainable Development, Environmental Science and Engineering at KTH in Stockholm. And we have reserved for the evaluation committee from our department, Dr. Josef Siri. Sorry. And then we have the supervisors. We have the main supervisor, Per Anders Hansson. And assisting supervisors or deputy supervisors, we have Associate Professor Åke Nordberg and Dr. Hanna Karlsson-Potter. We also have Professor Mats Sandgren from Molekylära Vetenskaper and Professor Martin Lee from Växtproduktionsecology here at SLU also. So before we start, Sarah, do you have anything to add to your thesis? Do you have a rough list?
Not at the moment, but I guess by the end of it, we'll find some.
Okay. Yeah. So then I leave the floor to you.
Thank you. And I would like to extend a warm welcome to everyone, both present here physically and those joining online, to my PhD dissertation. The title of which is the influence of Salix variety on the climate impact of biomass conversion routes. And in today's presentation, the outline would be, I would try to provide a brief background to this research of why is it important, the outline of the research that I have carried out during these years of my PhD, some results or the main results from this work that I would like to share with all of you. Of course, it's not possible to include all the results in the 30-minute presentation, but hopefully we'll take that in the discussion, and some future perspectives connected to this work. Most of us are familiar that since the dawn of the Industrial Revolution, there has been a rapid increase over the years of the three major greenhouse gases, which are mainly attributed to human activities, which has led to this phenomenon of climate change, which are all living through, with the increasing number of warm days every year. Our global economy runs on fossil fuels, which are one of the major sources of these greenhouse gas emissions. And reducing dependency on these fossil fuels for both fuel and for products is one of the key strategies for climate change mitigation. One of the ways that is suggested to reduce our dependency on fossil fuels is to replace fossil fuels as the source with biomass. Benefit being that the biomass, the CO2 emitted during the use phase of the biomass is already taken up during its growth. And the current policies and strategies that are in place, it is estimated that will increase the global biomass demand in 2050 by 70 to 200% compared to what it is now. And one of these sources of biomass that is cheap to produce or relatively cheaper to produce and do not compete with food stocks is lignocellulosic biomass or woody biomass. But of course, the supply and demand of this biomass need to be balanced with sustainability, so we do not end up with the same problems that we have with fossil fuels. That is, they don't end up being more polluting for the environment and for society. One of the sources of lignocellulosic biomass is an energy crop called as Salix, or commonly known as willows. Salix grows in an SRC system, or short rotation coppice, where after harvesting, the plants can regrow back from the stumps that are left behind on the field, which reduces the need for replanting after every harvest. They are also characterized by rapid growth. They can be harvested every 3 to 4 years. They provide high yields and have low input requirements. So on paper, or on theory, they are a very profitable or very effective source of biomass. And moreover, they can provide ecosystem services besides providing biomass, such as phytoremediation, which is removal of heavy metals from the soil or pollutants from the soil, provide protection from wind and snow, and also can improve local biodiversity and soils. During the 1990s, there was a big interest in energy crops such as Salix, particularly in Sweden and also in the UK, and due to government incentives, there was a lot of hectares of land being dedicated to Salix plantations. But over the years, due to ineffective policies and management, the area under Salix cultivation has decreased. But the current strategies or proposed strategies within the Swedish proposed strategies might see an increase in cultivation of energy crops such as Salix to up to 40,000 hectares by 2030. But of course, it remains to be seen how much of this is implemented. In the last few decades, due to breeding techniques, improvement in breeding techniques, many different varieties of Salix have been developed. And of course, these different varieties have different characteristics. What is interesting to find out is that due to these different varieties and different characteristics, what is the role of these differences when we want to use this Salix biomass for different conversion purposes? So with an aim to shed some light on this question, the aim of the thesis was to increase our knowledge on the influence of Salix varieties on the climate impact of different conversion routes using a life cycle perspective. The core of the study is including the variation within the Salix, incorporating changes in soil carbon. So are these Salix plants improving or are they beneficial for increasing soil carbon? And using a life cycle perspective to calculate the impacts or the climate impacts. We're looking only at one category here within the LCA framework. The first conversion route that was studied was production of heat by converting Salix into chips and then burning it in an incineration plant, which was done in the first paper. In paper 2 and 3, we looked at producing compressed biomethane, which is a substitute for natural gas in transportation. And in paper 2 dealt with calculating the energy and mass flows in a process simulation. And in paper 3, we looked at the climate impact of this produced compressed biogas or compressed biomethane, which is also known as CBG. And the third conversion process was a more futuristic, you can say in a way, of advanced use of biomass, where this Salix biomass would be fed to yeasts, a particular type of yeast, which would gather oil in their cells. And this oil could be extracted as a replacement or a substitute for rapeseed oil, which was done in paper 4. And this is all captured within these objectives of the study, which I will not read through line by line for now. The basis for all the 3 conversion systems is the Salix cultivation, where we have inputs in the form of machinery, pesticides, and fertilizers, which of course cause some emissions in the production chain. There are 6 Salix varieties that were included in the study. And we have yield and soil carbon data from a field study, which was done on the 6 varieties of Salix for 17 years. And we have compositional and biomethane potential data from lab studies, which were also done on the biomass samples collected from these Salix samples. After the Salix is harvested, it is transported, and then it goes into these 3 conversion routes that I described just before. In the first one, we have the production of heat, and we have ashes as the byproduct. In the second conversion route, we have biogas production, which is compressed to produce compressed biomethane, and we have digestate, which can replace mineral fertilizers. And in the third case, we have production of yeast oil. Now, I would like to explain in a little bit more detail on how the climate impact is calculated. We have the emissions that take place during the process chain, of course. Then we have the effect of the biogenic carbon. Now, the biogenic carbon represents 2 different pools or sources of biomass. One is the live biomass, and one is the soil organic carbon. The soil organic carbon changes were modeled using a soil carbon model developed here at SLU called the ICBM model. Then we have the substitution effect. So in the substitution effect, we looked at the land which was fallow and converted to Salix cultivation. What would be the effect of this change or substitution? And also if the product that we produce is replacing or a fossil-based source. This substitution effect was of the fossil-based source was included in the first 2 conversion processes, where in the heat production, we assumed that it is replacing natural gas as a fuel. And in the second case, it was also natural gas in transportation that the compressed biomethane would replace. Capturing all these 3 in the box of climate impact, and over the time frame of the study, we get the net climate impact. And two metrics were used to determine the climate impact. One is the standard GVP 100, which gives us the results in terms of CO2 equivalence. And the second one is the time-dependent climate impact, which takes into account the timing of the emissions. And we get the effect as change in temperature over time or of each year. Now, if we look at the soil carbon modeling for the Salix cultivation, we have these 6 different varieties. The F0 represents unfertilized varieties, and F+ represents fertilized treatments of those same varieties. Then we have the reference case of fallow. So if the land would remain fallow, then over the 50-year timeline, the soil carbon would increase to about a bit less than 10 tons per hectare. Then if we look at the unfertilized varieties represented here by dashed lines, we can see that depending on the type of variety, there is a wide variation in the amount of soil carbon that they can add to the soil based on the modeling approach. And an interesting result that we found out here that is contrary to some assumed changes is that the unfertilized varieties were actually able to store more carbon in the soil, about 1.6 to 3 times more than their corresponding or equivalent fertilized treatments. And no relationship between yield and greater increase in soil carbon was seen. For example, the variety Yor, which the unfertilized case had the lowest yield, had the highest increase in soil carbon, which means that it is hard or it is not it is hard to determine how much soil carbon can increase by looking at just yields, which means that a lot is happening below ground, which we still don't know about. And these roots are particularly difficult to study because we can't see the roots, and that remains an area that needs to be investigated more. Now I would like to talk a bit more about the effect of biogenic carbon. So when the salix grows, we have uptake by the live biomass during its growth phase, which is of course released during the harvest or the use phase. And during the first period, during the first year of harvest, first 3 years, the harvest levels are lower, then it picks up gradually. And here you can see, like, of course, the fertilization leads to increase in yields, leading to a greater removal of CO2 or temporary removal of CO2 from the atmosphere. But in the GVP effect of this, since there is no net biomass change during the life cycle, it has no effect on the GVP values. But if we would translate them into the temperature curves or the time-dependent climate impact, we can see that it has a temporary effect, of course, at the end of the cycle when the plantation is terminated. There is a time lag in the temperature going back to neutral. So this live biomass, especially in the beginning, because of the rapid growth of Salix, has a strong but short-lived effect on that global temperature. But soil organic carbon, on the other hand, has slower accumulation because it builds up slowly over time, but because of its slow decomposition rate, has a longer lasting effect on climate impact. So when we look at the GVP values going forward for the different conversion processes, this effect of the live biomass does not get captured in the GVP values, but we can see it in the delta T values or the temperature curve values. Now I will directly move into the results of the 3 different conversion processes. So the first conversion process was producing heat from Salix, and we had, looking at the functional unit of per hectare of land, we saw that what was obvious was that, yes, if we use fertilizers, it has a greater impact on the climate from the production phase. Because using fertilizers means that we need to produce these fertilizers, we need to spread these fertilizers, and also they lead to more emissions from the soil. But the soil carbon's effect for almost all the varieties was big enough to negate the climate impact of the production chain. Except, and so you can see the greatest effect, as I talked before in the soil carbon model, unfertilized had the greatest effect on the climate or negative climate impact, while fertilized beyond had the lowest. Now, if we would include the effect of the substitution that the biomass produced is replacing fuels, fossil fuels, the substitution effect is obviously dependent on the amount of yield that is produced. Because if you have a higher yield, you replace more fossil fuels per hectare of land, and which gives us a greater substitution effect, which is also seen in the temperature curves. So the selection of the substitution effect plays a very important role in determining how much is this substitution effect. Going forward in the future, if the biomass is not replacing fossil fuels, obviously the substitution effect would become lower. So the net climate impact, at least from a land perspective, we see that fertilization improves the yield, which leads to greater soil improves the yield, which gives more substitution effect, but it also requires more inputs during its production phase. And defining what is the substitution has a significant role on defining the net climate impact. Now, if we look at, if we compare the clones or the varieties in terms of per megajoule of heat produced, we see some similar trends, but we see that low yield, but when we have a low yield per hectare of land, that means to produce per megajoule of energy, it requires less land. It requires more land per megajoule if the yield is low, which also gives a chance for greater soil carbon sequestration as more land is needed per megajoule. So in that case, the varieties with low yield had a greater climate mitigation potential. But if we look at the delta T curves, because of the biomass, the effect of the live biomass, we see that all the unfertilized varieties had lower climate impact than the fertilized varieties. So how we view the climate impact really depends on what metric are we using, because different metrics capture different aspects of the system, and also what is the functional unit, or how are we comparing. If we want the best use of the land, we would use varieties with higher output or higher yield, while if we want the most mitigation per unit of energy that we are producing, we would choose a variety which would have greater soil carbon sequestration potential. Now looking at the second conversion, which is producing compressed biogas, what we could see is that the digestate has a huge role in the soil carbon sequestration, because about 50% of the biomass that goes into the system ends up in, or 50% of the carbon in the biomass ends up in the digestate. So when this digestate is applied back to the soils, it can produce a tremendous soil carbon sequestration effect. And one thing of importance in this was that the biomethane production had a high energy demand, but it had a low impact on the climate. It was because in our system, we assumed a Swedish energy mix, where it was assumed that the energy needs in the biomethane production facility would be met with electricity and biomass, which had low emission factors. So if we would produce biomethane in another country with a different energy mix, obviously the portion of, or this black portion that we see of the biomethane production might increase significantly. And now if we look at the substitution factor similar to production of heat, if you have greater yield per hectare of land, it would produce a greater portion of natural gas as a fossil fuel, which can be seen here, for example, for the high-yielding variety 2-dis or beyond. So it can replace a lot of it can replace more amount of fossil fuels, leading to a greater substitution effect. And also it will, and if you have a higher yield, it will also contribute to a greater digested soil carbon effect, as we end up with a higher amount of digestate from the portion of the biomass that is not converted to biogas. Now, again, if we compare it on a different functional unit of per megajoule of the biogas or biomethane produced, what we see is that the varieties are very similar in their performance compared to the previous slide, where the varieties, where there was a huge difference between the individual performance. In per megajoule unit, there is a lower, the net effect is much close, the net climate effect is much similar between the different varieties, and which is also seen in the climate impact in terms of delta T. And what we found was that replacing the current natural gas that we have in Sweden with compressed biomethane from Salix would lower the climate impact by about 35 to 60%, depending on the variety that we are using, even without including the soil carbon sequestration effects. And then the last conversion process that we looked at was using Salix biomass to produce yeast oil by fermentation with yeast and then extracting the oil from that. In this case, we had kind of like a half, we did not assume that the yeast oil would replace rapeseed oil, so we did not include the substitution effect of that, but we did include the substitution effect of the land use. So basically, if the land would continue being fallow, or if it would be converted to Salix. Taking that into consideration, we could see that there were two varieties, Yor and Tura, which would almost give us climate neutral or climate negative oil production per kilogram of oil. And even without including the soil carbon effect, because the soil carbon effect really depends on what are your starting soil conditions and where is the salix being grown. Even without including the soil carbon effect, the GBP values per kilogram of oil were quite comparable to the GBP values calculated from an older study for Swedish rapeseed oil. So at least in terms of climate impacts, oil produced from Salix could compete with rapeseed oil that is currently being used in Sweden. But of course, the climate impact is largely dependent upon the emissions from the cultivation phase and the soil urban sequestration. And while it is easier or more, we can say with more certainty what can be the emissions from cultivation because we know about the machinery use, the soil carbon sequestration is something that is more dependent on the climate, on the soil types, and of course, that involves more uncertainty. And similarly, if we would look at the delta T curves for these different varieties, which also includes the effect of live biomass, we can see that they provide a high climate negative effect. So they can have two of the varieties, which are Tura and Yor, can provide a cooling effect on the climate, while Turdis almost provides a cooling effect on the climate for these 50 years of the study. Now, if we would try to combine what we see across these different conversion routes and what are the effect of the Salix varieties, we see that the two most important characteristics that determine the climate impact are the yield levels of the biomass or the different varieties and the soil carbon sequestration potential that was calculated based on the field studies. But these two are not, they are dependent on the type of variety that we use. So if we include more different varieties, the effect will be really different between them. And the functional unit that we choose to compare these different varieties determines what is the relative importance of the characteristics on the climate impact. So if we try to draw a correlation between the different aspects of the system, we see that from a land use perspective, from a per hectare perspective, harvest levels was the determining factor for the climate impact. But from a product perspective, so if we look at per megajoule of energy or kilogram of oil, soil carbon sequestration effect was really the aspect that determined what was the climate impact of the different varieties. And with that, I would like to say that in most biomass comparison systems, the variety effects are not taken into account, but we treat biomass or as a general, there are many studies which look at Salix, but Salix as a whole. It does not specify what type of Salix are we talking about. But as we can see from the study, that choosing a variety has a really large effect on the overall climate impact, which needs to be taken into account in systems analysis. Because biomass are very context specific. It depends on what variety we use, which land are we growing, what is the climate. And if we talk about some future perspectives, of course, in studies like this, we want to have more detail so we can make more accurate predictions or make more accurate analysis of what is the climate impact. We need to know more about what is the below ground biomass accumulation, because as we have seen, you cannot estimate what is going to be the changes in soil carbon looking at just what grows above ground. Interactions with soil and environment, when we grow them in different types of soils with different environments, what are the effects going to be? There are many other factors or many other characteristics besides the ones that were included in these studies. For example, albedo, which should also be characterized for the different varieties so we can make more accurate climate predictions. And of course, we have looked only at climate impact, which is a small part of this whole sustainability picture. What about water use? What about effects on ecotoxicity? And also, one major factor for the climate impact, as we saw, was the substitution effect, defining what the substitution was. really determines what is your final climate impact. So having a dynamic substitution when we are talking about systems which we are predicting 50 years into the future, we cannot expect that what we are substituting now will be the same thing we will be substituting 50 years into the future. But at the same time, we need to make LCAs or systems analysis like this easier to use so that we can adapt to newer emerging varieties, because there are newer varieties being developed all the time. Also, if farmers and policymakers want to use these tools, they need to be able to use it more. It needs to be easy for them to access and also apply. So there is always a balancing act between having more detail and having a better ease of use. And with that message, I'd like to end my presentation. I would like to thank you all for your support, friendship, and love over these years.
Thank you very much. We switch computers and leave the word for the opponent to give his perspective.
Thanks. First, thank you. It was a really, really interesting and really nice presentation. I personally really enjoyed it, content-wise, and as you did it. So, as I said before, my PhD thesis was in a similar topic, only another crop. So it was quite similar to what you presented. So it was really nice to see it for another crop. I tried for my presentation to look a little bit in the beginning, why is your topic important, or is it important from a scientific point? So I think it would be better if I had started before you, because it's more introduction and not a summary. But yeah, it is really important, as we see. I started to look a little bit, if we're talking about climate change mitigation in Sweden, where are the emissions are coming from? And I think, as we all know, energy production and energy supply to transport to industry is the major point if we're looking at CO2 emissions. It's not only so in Sweden, but it's also the same in Germany. And then I looked at where the emissions from the energy sector are coming from. And I was positively surprised it's a little bit different picture in Germany, because we have a lot more coal fueled energy. So I thought Sweden is already on a really good way, but still I think we have some major problems to tackle. And I think that is really an important part of your work, that you looked at these points, especially if you're looking at transport, if you're looking at energy, if we're looking at electricity, how can we substitute? How can we substitute coal, natural gas, and oil, at least partially? And I think the second really important part is when we look at how is the future of carbon mitigation. Often people think, oh yeah, it's fine if you're getting carbon neutral, but that's not enough. And I think that is an integral part what we can do as agriculture. That we are one of the few sectors who have really the possibility to act as a carbon sink. And I think therefore it was also your results in regard to SOC, it's really crucial. And I have a lot of questions in regard to that, also because I didn't expect the connection to a more extensive agriculture in regard to an increase in SOC sequestration and soil. So for me, that was really, if I would say the one major thing I learned, it was that part, because I didn't know and I didn't expect. But yeah, we have to get carbon neutral. We have to act as a carbon sink, and there I think it's really a valuable part. Yeah, as I said, it's on the twofold challenge for us: to reduce the energy consumption or the CO2 emission associated with energy production and consumption, and develop real carbon sink. Often agriculture is presented as a solution, but I think this graph mostly all of us already saw and know. If we look at planetary boundaries, agriculture is not only a solution, but it's a major contributor. Here you see in the dotted areas, what are the risk, or in which planetary boundaries we are already over the boundaries, and where has agriculture a large part. And so I think we are on the one side the solution, but on the one side we are also a major impact, and we have to connect these two parts in a way. Yeah, as I said, and it's not only climate change where we as an agricultural sector have negative emissions, but also biosphere integrity, land use system change, so at least, or major part in the global south, but also freshwater use, the use of nitrogens. And if we look at perennial crops, they are often stated as one major tool or a major solution that we can make agriculture a little bit less harmful, especially if we're looking at biosphere integrity, but also at climate change. And I think that was really proven to a part, at least if you're looking at climate change through your thesis. And if you're looking a little bit at perennial crops, I think most of you are familiar with that. I worked a lot with perennial grasses. So for me, it was interesting to see the same applied to woody perennials. We have also perennial wild plant mixtures, which I think is, at least for Central Europe, also an interesting opportunity, which we see similar effects. And if you're looking at the advantages of perennial crops, I think you already named some of them, but I think the major point is what we also see in the comparison between the fertilized and not fertilized variants. It's often that you can grow them with less or no input of agrochemicals. If you're looking at other perennial grasses, for example, miscanthus, we often see even nearly no yield difference between fertilized and not fertilized variants. Or that we not only, I think you applied, or in your trial, it was 100 kg of nitrogen, we have it often less, so 40. So we have really nearly no use of agrochemicals. And I think the deeper root system is also a point, not also for SOC increase, but also of provision of soil stability, of soil health, of soil quality. If we frame it a bit broader, they have at least the potential to enhance biodiversity. It's true for miscanthus. I'm not sure how it's for poplar, might be. And I think the major point, it can capture carbon in the soil. And I think what is also a really important advantage of perennial crops is that you can grow them on marginal land. So, and that will also be a question of the reference system, how many marginal lands you have here, which are really unused. Because we also work with this kind of maps. I'm sometimes a little bit skeptical if really this is all available for us to use it. But at least you can see we have in Europe, and we have the same map for Central Europe, large areas which are highly marginal lands, which cannot, or from an economical point, it's often not viable to use it for agricultural land, and which you could use, for example, for biomass production. And I think also if you're looking at Central and Northern Sweden, there should be, based on this recommendation, land available which we could use, or where it would make sense to use it. And then I looked if it's possible to grow other perennial crops, because I was interested, does it really make sense to use willow, or should we use something else? But apparently it's really, if you're looking what is suitable for northern region, it makes really sense to cultivate these woody perennials. As you see, miscanthus, which I mostly worked with, is totally not suitable for northern region because it's not really cold, or a lot of varieties are not really cold tolerant. What I was also found quite interesting, because I didn't know it, the broad variety what you can do with poplar biomass. In my mind, it was often only combustion. I think in Germany, we have some companies which extract lignin and use lignin for different applications, but I didn't know that it's so broad. And I also didn't really imagine that we could use it for biogas. So we tried it with miscanthus, which has not a similar composition, but is also high content of lignocellulosic components. But I didn't know that, and it was quite fascinating what broad use possibilities we have. And I think if we think about what are the most important factors influencing at least environmental sustainability of different value chains, it is really the 3-4 factors you looked at. Therefore, I think it was quite interesting. here you see the GHG saving potential per hectare depending on the yield and on the utilization pathway. And we did nearly the same what you did. The dots are different miscanthus varieties on different sites. So we looked really what are the difference, and the main factor is really the yield. So we also looked at chemical composition. Does that has really influence on the different utilization pathways, but it's mostly the yield. And here you see it depends on what yield do I have and what utilization pathway do I have. So that is really the question, how much biomass it produced and what do we do with it? And I think that is an environmental decision, but it's always also an economic and social decision, what we want to do with it. So with that, I have also some questions what I would be interested to discuss with you. And what we didn't include in this study, what I would change now, so that was, I think, one of my first publications some years ago, is to include soil organic carbon changes. And that is also another one from Willow, but I think it's comparable to your results, that it really makes a huge impact if we include soil organic carbon changes or not. I'm sometimes a little bit skeptical about it, but I have various questions in regard to that. So I think it's an interesting topic and we have to include it more. And that is, I think, also a change we see a little bit in the agricultural SEA world. I don't know, 5 years ago, nobody really included, and now we have a little bit of switch that is more and more included. And as your results show, it's important to include it. Yeah, and as I said, that would be more like a nice introduction to your presentation. I think it's really important topic because you have the marginal land to produce short rotation copies. You have the high yield, and I think it's one of the most suitable if we look at perennial crops, which we can use here. And I think the questions you addressed are really the important one. It's a question of variety, it's a question of yield, it's a question of how much soil organic carbon can we sequester, and for sure the utilization pathway. So yeah, I think probably I would have researched similar points, so it's quite interesting. Yeah, and now I'm really looking forward to our discussion. So
please.
Yeah, the first one, it's like an easy entry question, because I showed, or you also showed, that from a scientific point, it's really important questions. And what I thought about is, what do you think from a practical point? So for a farmer, for a company, is it a discussion point what we have at the moment in Sweden? Are there already people using it for example, for biogas, for combustion, I can imagine. But do you think it's really also questions which are relevant at the moment for the broader society, or which are asked by the broader society?
I think at the moment, there is low interest in Salix, or from farmer perspective, because what I found during the course of my research in this PhD was that initially I thought there is high interest in Salix, and because it's also influenced by where we are, because there are some Salix plantations around here, and you can see them like on the other side of the road. But as I have looked, and according to the statistics as well, the area under Salix cultivation has been decreasing. And that is, of course, due to a lot of factors, because during 90s, early 2000s, there was a lot of focus on biomass production, biofuels, where now it has shifted more towards electrification. So, but at the same time, electricity cannot solve all the problems. And there are really sectors where it is really hard to remove the use of fossil fuels. And also electricity cannot produce fuel, and it cannot produce feed for us. It cannot produce some other chemicals for us. So it would be, I think, really interesting. And if we're talking about energy security in a way as well, or not just energy security, but security of having raw materials to produce the things you need, I think there should be more focus on finding more biomass sources. And one thing I'd like to point out as well, when you mentioned about marginal lands that are available, interestingly, the area that is under arable land in Sweden is also decreasing year after year. And it has decreased by several thousand hectares in the last few years, I think. So there is also arable land, perhaps that is not as productive, which could also be used for Salix cultivation. But the farmers need to be motivated enough that they will take up this energy cropping system. And I had read one article about the failure of, it was termed as the failure of Salix. I think it was on Ireland, which had a similar vision during the 90s, and in the UK, in other parts of the UK as well. And one of the major reasons why Salix was not successful was that they tried to promote it to farmers who had animals or other food-based crops, and they saw themselves as producers of food. So from shifting from food to producing energy or a biomass was very different or alien to them. So there was low uptake on that part.
Yeah.
So it's like changing farmer attitudes or stakeholder attitudes as well.
It's for us, we have with perennial crops such as miscanthus a whole also similar experience that it's important, but the uptake of farmers is hard. And it's not easy. And I always also started with the idea that it's important also in the farmers world, and it's made the same experience as you, that it's not. But that's a good point to the next question, because you said, okay, the land or the agricultural land is decreasing, because I wondered a bit if green fallow is really the right reference, because when I look, at least in Germany, we have not much land available. We always talk, we have land where we can do something, but it's cultivated. If it makes sense from an economical point, it's something different. But do you think that green fallow is really the right reference, or or let's frame it differently, why did you selected it?
Which selected green fallow based on the field study, because where the field was established, it used to be fallow land before. So it was agricultural land in the past, which was taken out from agriculture, then it was just remaining fallow. And then it was changed under this field study to Salix cultivation. That was done in the early 2000s, so a long time ago. That's why we chose the fallow land to show like if this land. So it was very case specific.
What do you think would change, or what changes would you expect if we say, okay, the reference would be, I don't know, farmers switching from wheat cultivation or?
I mean, then obviously, I mean, one thing that really is dependent on the selection of the change in land use, I think, is the initial soil carbon level, which can vary a lot between different plots of land, depending on their use. In this particular field study, what I realized is that the initial soil carbon was on the lower side. So this land had a lot of capacity for storing more soil carbon, or the rate of increase was much higher over this period of the field study. But if we would take another soil, which would maybe perhaps rich in organic matter, then obviously it would probably still increase compared to annual rotation of crops, but the rate of increase would be lower.
Yes, I would expect the same. What I wondered a bit, why did you, and that is also a little bit later on connected to the soil organic carbon sequestration, why did you choose 50 years as a reference period?
Initially, I don't know if it's kind of like just a tradition or the way of doing things. We had other studies here which had also looked at energy crops. And then the study period was 100 years. So we changed it from 100 to 50 years because it captures 2 full rotations of the Salix, which includes 25 years each. And it's also we thought makes more sense to extrapolate 16, 17 years of data over 50 years rather than extrapolating it over 100 years. So it was kind of a little bit from the practical viewpoint as well. And it makes it more realistic. And I think also it makes more sense for the soil carbon modeling approach, because that model was initially used for agricultural crops. If we want to, I mean, in any model, the longer you stretch the time horizon, the more uncertain the results become. And if we would increase it to 100 years, then obviously the soil carbon also, I mean, the rate of increase slows down, but it still is a lot of increase. So it could give you like really big numbers that we could substitute. We could just grow Salix and save the planet kind of situation, but which I think is a bit far from reality.
There I also wondered, because I was a bit surprised about the high soil organic carbon sequestration numbers. I think we have it also in other perennial crops, and we often didn't include it because we also thought, okay, we don't know what happened afterwards. Perhaps then we have a decrease again, and so. And also, if we see, okay, with the ongoing climate change, we need more input of organic materials only to have a stable soil organic carbon content. And there I wondered, on the one side, does such models include future climate change? And the other one, did you try another soil organic carbon sequestration model to validate a bit your results?
In terms of trying a different model, no, I didn't try another model. I just used this one because it was out of some practical considerations as well, because this model is relatively easy to use and it was calibrated using soil sample for the climate and this thing of Uppsala, because it was developed in SLU kind of. So we didn't have to estimate the parameters, how they might change for different climatic conditions, because then again, then you have it's another assumption you are adding on top of the assumption. So so that's why we chose this soil carbon model. There have been, but yes, I mean, but it's we did not, but it's a static soil carbon model in a way that the parameters do not change over time, or the parameters of how much, how the decay of the soil organic carbon changes. So it assumes, because it's a simpler model, it assumes that, okay, the decay constants will remain the same. The effect of climate will also be the same.
Yeah, so it doesn't include.
No, it's not a dynamic soil carbon model. Obviously, I mean, there are other soil carbon models which are dynamic in nature, but it also increases the complexity of the modeling approach. And interestingly, I think I read across one paper a long time ago where they had compared different models, both simpler and more complicated ones. And they did not find a big difference. I mean, the range of error was basically similar for all of them. So all models are wrong. It just gives us an indication. But taking these numbers and saying that if I grow Salix, I will get 20, 30 tons of carbon dioxide removal, that's a bit preposterous. It gives us an indication. It's more for understanding the capacity of the plant, but should not be used to, I don't know, to create a carbon stock number that can be used in setting some policy or setting a target.
Yeah, that is also a question which I have later. If you're talking about stock, one thing what I wondered a bit, why did you choose a soil horizon level for the stock model of 20 centimeters? Because I'm not sure, I imagine that the depth of Salix is much deeper probably of the roots.
Yes, it is deeper, but it is not as deep as other roots. But that is the soil horizon of the 20 centimeters or just the topsoil. That was purely based that we had during the field study that measured the soil carbon in the top 20 centimeters. So it was purely on the basis that we do not know enough about what happens below that level. So better to model what we know than make assumptions about what we don't know.
No.
So it was based on, because I used the soil carbon values to kind of calibrate the difference in biomass allocation between the different parts. And if I would include, the deeper soil levels, then of course that would increase the uncertainty even more. So the net soil carbon accumulation would probably be higher than what we have now. But interestingly, in other studies where they had looked, and there are very few studies which actually look at the biomass accumulation over time, because that is something very difficult to do. We can't see what happens below ground. They found that about 70% of the roots were in the top 20 centimeters.
Mm-hmm.
So the rest 30 centimeters, at least for the specific Salix that they had looked at. So majority of the soil carbon is increase is in this top 20 centimeters.
Yeah, I also think it's always better to be conservative. I only wondered because I think also for miscanthus or other perennial crops which we looked at, they have like a root depending on the soil type, 70, 80 centimeters.
Yeah.
Still, it's not much available. But yes, what I also wondered, because, and that is a little bit why I came to the time horizon of 50 years. You have now a soil organic carbon sequestration over 50 years. But if you look at the global warming potential, it looks at 100 years.
The GVP values, yeah.
How did you include it? Because you have value for 50. Did you discount it anyway? Because, or did you assume, okay, it will be stable for another 50 years?
The GVP values we calculated at the 50-year mark, but it's the metric itself which assumes that it's 100 years. We did not discount it in that way. So it's we're looking at what will be the effect over these 50 years of how much CO2 is getting removed in there and multiplying with the characterization factor to achieve the GVP values. But that's why in the chart where I showed the delta T curve, it's important in that because there is always this question of how long will this carbon stay in the soil? If we maintain because it's very happen later on if we change the soil management type. So here we drew the boundary at 50 years and said, okay, here at 50 years, this is what we see.
Because we sometimes then did discount it because if you multiply it, you assume, okay, it will stay because in the calculation you say, okay, we have GVP 100 factors. If I multiply it, I assume it stays for this time at least in the soil. Okay, because I think that is a factor which can decrease the effect of soil organic carbon sequestration if it, I don't know, if it released because I don't know, the farmer is cultivating wheat.
Or just as a fact of increasing temperatures. I mean, here we treated soil carbon same as we treated CO2. So we just assumed that how would you treat the CO2 emissions? We treated it the same way, that it's not an emission, but the removal of CO2 from the atmosphere.
And you already mentioned it, but I also thought about it. You said we have here a really great potential because the stock levels in the beginning are really low. Did you compare it with a reference or with an average so that you get a feeling, okay, how it's on other sites?
For these varieties?
Yeah, or I don't know, the stock level in the soil in the beginning because you said it's low. So how much lower is it?
I don't exactly know how much lower it is, but I think in these soils it was around 24, 30, something like this in the top 20 centimeters, which is, I would say, I mean, it's not less than half of what is the typical average. But we haven't looked at it in this study because the values we used, we used measured data from different, from this particular site. What I know, which unfortunately I think is not published, is that they had similar experiments in different parts of Sweden. But those are not published or the data is not available. So that would have been really interesting. What I know is that they had a similar site in Gotland, which is an island, but that had sandy soils. And initially there was a high increase in both biomass and carbon, but because of the sandy nature of the soils, Salix loves water. So the soils do not store enough water. So there was rapid growth in the first few years, but after that, it wasn't very good and they had to end the cultivation.
That would be also some questions of mine in regard to the yield levels. I also thought they didn't publish it yet. Is it right? Because I think you referenced the initial paper of 2005, but the yield data is not yet published.
Yes, the yield data is not published in that paper, which deals with the field study, but they had measured and calculated, and they had stored the data because the field trial is still ongoing.
Okay, because it would be really interesting if somebody.
And what is interesting is that there are other groups here who are looking at different aspects of it. I know that they're looking at even the difference in composition of soil carbon and the interaction with the microbes for the different varieties, which apparently is also different. So it's not just they are storing different amounts of soil carbon, but the quality of the soil carbon is also different between these varieties, which is interesting, but I don't know how easy it is to incorporate things like this into LCA.
Probably. It's also the question if it's worth it, or if it's only looking more certain, but it isn't more certain. But I wondered the yield of the different plots. Was there a high standard deviation? So was there a high uncertainty in the yield?
I think if I remember correctly, the yield levels were really dependent on what was the weather or the climate in the past 3 years. So whenever there was a dry spell, the harvest, especially if it was dry during the second and third year, I think, or the first and second year, then the cultivation levels were lower. But except for one harvest rotation, the other harvests were quite similar to each other, but there was a big drop in one particular harvest. And I think that was attributed to like it was a 2 dry years in a row or something like that.
Did you compare the results with results from farmers? Because what we saw that our results were never really comparable to farmers, because we kind of looked at every plant and cut it by ourselves at a really low depth. And if we talked with farmers about their yield, it was a real big difference, which the yield from farmers were lower. Did you experience similar things, or did you check?
No, we didn't have any interaction with Salix farmers in Sweden, because first of all, there are not many Salix farmers in Sweden. And I think a lot of the areas which are under Salix cultivation are either research plots or they're owned by breeding companies who are like, because there is a breeding effort in Sweden as well, especially in the south of Sweden, where they're developing new varieties. And these varieties were developed by them.
Okay. I also wondered, you have compared the fertilized and the not fertilized plots. And for other perennial crops, we see that the yields, even of non-fertilized plots, are quite stable over 20-25 years. Still, I'm always not sure how I incorporate it in LCA, because I think, okay, we take nutrients off, we remove them, and we should include it somewhere. So my first question would be, were the yield of the unfertilized plots stable, or do you already see after now, I don't know, it's now 20 years, a decrease?
During the period where they measured in the field study, they only had 5 harvests. So during that period, you could see a small decrease, but not like significantly different, that it didn't become half. But from the others who were involved more in the field study, what I hear is that the yield levels do decrease over time. And it makes sense because, I mean, if it was fallow land in the beginning as well, probably it wasn't, I mean, agricultural land which had been under agriculture for many years, then converted to fallow for a few years, the nutrient content will not be that high. And probably, I mean, after some years, the yield levels will decrease. However, on the other hand, willow also forms colonies in the ground, and the advantage of harvesting Salix during winter was that during winter they transfer most of the nutrients to the roots, so there is not a huge loss of nutrients. And because of this fear that, okay, if we make a prediction of same harvest levels for 50 years, then maybe we should not include the unfertilized varieties. That's why for like the two other conversion routes, which shows that, okay, we will look only at the fertilized because it makes more real. It's maybe perhaps more realistic to assume that they will continue producing if they keep on getting fertilized.
That is also a question which I had. The fertilizer applied, is it based on removal, or is it standard practice, or?
No, I think the fertilizer, I mean, the levels that we chose, we try to keep the same parameters as the field study, so as that we do not assume a different level, because then it changes a lot of things, because we're making assumptions of an assumption kind of. So these fertilizer levels, I think they applied the fixed fertilizer amounts to all the different varieties, which I mean, once you do the field study, probably it makes sense that all varieties do not require the same amount of fertilizer, because there were two varieties also which did not have an improvement in their yields upon application of the fertilizers. So they obviously had a worse climate performance compared to the others. And I think like we need some more studies, or based on these field studies, they need to collect more. If we have more data, then we could adjust the fertilizer levels in our studies as well. Then we would get a more complete picture of the cultivation chain, because the cultivation should also differ depending on variety. But of course, in reality, it's much more difficult to assume how much fertilizer a farmer should apply every year. Probably they would apply the same amount every year.
Yeah. And I think it's really hard to do a comparable field trial if you change something like that.
Because there are too many variables in field.
Yeah. But what would you say from a methodological point? Would you, I don't know, if you do another paper, would you try to add the removed fertilizer as you could do, I don't know, a negative credit, or you think, oh no, it's, as we have stable yield, it's fine?
I think I would prefer to not keep the same amount of fertilizer from a methodological perspective, because, I mean, we can make some certain either estimated guesses or talk to more experts, or the ones who are involved in the farming. Maybe they will have a better idea of it. But I would say, like, expecting that all fertilizer, as I said before, I mean, I don't think assuming the same level of fertilizer for all of these varieties is, I mean, we should probably, I would like to change it so that we can see greater variation between these varieties.
A question you already mentioned a bit. I also thought about your reference system, not only Greenfellow, but also the other ones you looked at. And there you already mentioned a bit, how would it look like in future? Could we use, I don't know, a marginal future mix for electricity, something like that? But what I also thought, when you looked at biomethane, I think you wrote that biomethane is mostly used as a fuel for cars, when I remember right.
Not for cars, I mean, it's used mostly as a transportation fuel, at least in Sweden.
But is it then really substituting natural gas?
I mean, it did substitute natural gas for the buses which run.
Okay, so that's really...
So this is already in practice, like something which is happening, because there are buses which run on both methane, natural gas and biomethane at the same time. Like,
Okay, because that I wondered a bit if that is the right reference, but if they're running on.
But I mean, if going for, I mean, that also depends how many cars are running on biomethane now, or natural gas that would be converted to biomethane. But probably it could also replace normal like petrol or diesel cars in the future.
How would you solve the problem, which you also mentioned, that in the future we have a different energy mix? So if you would do the LCA again, how could you think how could we include such a prospective energy mix?
I think if I would do it again, then I would choose like something of a dynamic substitution system, where like based on like the policies and based on the strategies that are in place, which of course they also keep on changing over time, but would assume like maybe 10 years, maybe at 2030, if the target is that the energy system or the transport system should look like this, then what would we be substituting then, more or less, most likely? Then at 2040, what would be in at 2050? And I think we could also tie it into the overall climate targets as well, because based on the climate targets, the governments have, or different countries have proposed different strategies or pathways to reach these targets. So following this kind of like a dynamic substitution, which follows the predictions as of now. But again, it's a prediction.
Yeah, it's highly uncertain. What I also wanted to ask, if we're discussing about methodological choices, you explained in the beginning a little bit about attributional versus conventional LCA. how would you describe your style of LCA?
I think the first two ones are more consequential, because we are looking at what will be the consequence of like changing the system from a fossil-based, fallow land fossil-based system to this biomass-based system. I think the third one, where we looked at production of yeast oil, because we are not substituting something. We're not saying like, hey, this is a replacement. We can replace rapeseed oil with this. It's more like perhaps complementing. So I would say that is more attributional or kind of like a mixed approach, because we still have the land, which is fallow and not on Salix, but we don't have a replacement for the product. We're saying that it is comparable to rapeseed oil. So like, I mean, the demand for oils usually keep on increasing over time. And then if we are in maybe we can think about replacing some of that oil or some of the imported oils with this oil that can be produced from Salix.
Yeah, that's what I also think is it's probably nicer strict consequential, nicer strict attributional. It's sometimes a little bit a mixed attribute approach. What you see quite often.
Yeah, I think it is something that always is debated, like which approach should you choose? Like, should you be only consequential or only attributional? How should LCA be? Like, but yeah, sometimes I think we end up in a mix of both.
If you would have chosen substitution, what would you think? Or how would be your pathway? Which oil would you have replaced?
In the study that we had assumed that it is closest to the profile of the fats that is produced by these particular strains of yeast are more similar to plant or seed oils. And the seed oil in this case was rapeseed oil.
Yeah.
So I would think that in this case, that would be the closest substitute we have. But of course, I mean, you can also, because rapeseed oil is one of the most common oils that is used, at least in Sweden. Now, if we would change the yeast strain, that has also the possibility that you can have different types or different characteristics of oils. So you could also replace like palm oil or something. But of course, that is very expensive, or it's like we are extrapolating it a bit. We need to do some field study or lab studies on it first.
That was also a question of mine if we're talking about the yeast oil production. I think in the yeast oil production, you also included not only the different yields, but also the different biomass characteristics, if I understand it right, or didn't you include it there?
Yes, I mean the yield, the production of the yeast oil was based on the available sugar content in the varieties. And there was not a huge difference in the sugar composition between the varieties, but there were some differences. So combined with the yield and the other, so it's like how much sugar are you getting per hectare of land and how much of this is getting converted into the kilograms of oil. And this was done in a process simulation, which was again similar to another, is based upon another study which was done in that which, so it's a simulated process. What would be interesting is that if we actually do these tests on Salix samples and more, and maybe do it more on the pilot scale rather than on the lab scale, because sometimes the lab data and the pilot scale data are very different. And what is interesting is that Salix, some varieties have also some inhibitors in them. So if you have a high concentration of inhibitors, which was not a part of the compositional analysis that I used, because that compositional analysis only looked at the monomeric sugar composition. So these inhibitors can also play a big role or can help us predict, like, is this variety suitable for yeast oil production or not? Because they might have some inhibitors which will kill the yeasts, which is very often what Salix was used for in the past as a painkiller or an antimicrobial.
If we're talking about biomass characteristics and also breeding, except from these inhibitors, do you think it makes sense if we want to focus the breeding in a direction? Do you think it makes sense that besides yield, we also try to improve biomass characteristics? Or would you say, okay, the impact of the differences characteristic is so small compared to difference in yields that it doesn't really matter?
I think it depends kind of like what we view or what is our future view of what this Salix biomass will be used for. If we're talking about production, just as a simple fuel that we're going to put in a boiler and burn it, then of course it doesn't matter as much, except maybe the ash content of what this biomass composition is. But if we're planning to use it in this bigger bioeconomy approach, where we might produce chemicals, fuels, and even more specific, maybe some more specific chemicals or like medicines and things like this, then I think the yield or the character or the compositional and of these different varieties does become more important. And I have seen like there are studies, and there are not just studies but also breeding efforts going on, or efforts to even capture this, like what are the differences in not just yield but also composition. There are different how to say, like wood or tissue structures within the Salix, which can also vary between different varieties. So some of the structures might be more easy to, might not even require pre-treatment, or might be more easily converted in chemical and biological treatments. So if we are planning to use it as a substitute for fossil fuels in a more complete sense, I think we need to look into this breeding towards more favorable characteristics. And there are efforts, I think, which are going on in that direction.
Yeah, I also agree. I think it makes sense as soon as we target valuable compounds.
Yeah.
For most of the other things, we also tried different miscanthus varieties for bioethanol, and I expected that the biomass characteristic has a huge impact.
Yeah.
And in the end, it was a yield, 90% of the impact and 10% characteristic.
Yeah.
So it's not really, or it was at this point not really worth to focus for, at least for this production pathway on it.
Yeah.
But I agree, as soon as it's more valuable, then it makes sense.
Yeah. And I think at like the current scenario, if we look, like one of the reasons I feel like biomass use hasn't been very successful is that we have been using it traditionally to replace energy, which it is having a hard time keeping up with the other renewables. Yeah. So we should better use it for stuff that is more the renewable, not for energy purposefully, or not the which can be fulfilled by other renewables, but more as a mix for this bigger replacing fossil fuel bioeconomy concept.
Yeah. Some things in regard to the biomethane where I wondered a bit, if we're looking at this utilization pathway. I think the major energy impacts were for hygienization and cooling, both which wouldn't be normal in Germany, or at least if you're using manure, we don't have to do it. You can do it, but it's not mandatory, and therefore I think nobody does it. So we can use manure without the step as an input. And I was wondered, why cooling? Because in Germany we have internal heating in the winter, but even in summer, which is probably a little bit hotter than here, we have no cooling steps.
No, the cooling demand was mostly from the compression stage.
Okay, that's
so it was like
okay,
when the turbine, I mean, not the turbine, but the compressor pump needs the cooling demand kind of.
Okay, for the biomethane production, because I wondered a bit.
No, not during the production, but more like during the upgrading and compression of it. Yeah.
And the hygienization, is it mandatory in Sweden, or did you only include it?
I am not sure if it's mandatory. But during when we were building up the framework for the study, I think it was during our discussions, we decided that it is better to assume that you hygienize it so it's safe to apply, rather than somebody pointing out that why didn't you include hygienization, because it's manure, there is always a danger of animal microbes ending up in our agricultural soils.
Yeah, because I only checked for Germany, and it's not recommended, and I think as soon as it's not recommended,
yes, I mean, no one will do it unless it's a rule, because it requires a lot of energy.
What I wondered a little bit in the beginning, why did you only look at climate change? So what was the basic idea to say, okay, I focus only on one impact category, and you said yourself, okay, it's only a small part of the sustainability debate.
I think there are I can see there are two main points to it. One was how the study was structured from the beginning, but also because, and the second main point, I think it was due to we don't have enough available data on these Salix varieties, because this PhD or this research area was also a part of a bigger research area at SLU, where they had looked at breeding Salix for looking at breeding of Salix and its advanced and its optimized usage. And this, the research here was part of a work package looking at the climate impacts of these different varieties, or some of these varieties. And they tried to use as much. And during the course of this research project, they looked at many different aspects of it, starting from breeding, conversion techniques, the morphology, composition, and this work package was more on the climate impacts of it. But I agree that if I had more data available now, then I would definitely include more of these different impact categories. But to include them, some more variety-specific data is needed, because otherwise, then I would again, it would not be different from other studies that have already looked at or have done a more comprehensive LCA of Salix, including different categories, because we need something to differentiate between these varieties.
And you looked at two impact categories in the field of climate impact, and I think it's interesting, but in the end, the results are this. Yeah, so if you only compare different value chains, for example, the final results are the same. So or in my opinion, you don't get to another conclusion.
There is slight difference in the rank. There is a difference in how the varieties are ranked in their performance between the different, or some of the conversion processes. But I agree that there is not a huge difference, but we gain, what I think is the main advantage of using that is we gain some additional insights. For example, this biogenic effect, where the CO2 is taken up by the biomass, that has no effect on the GVP, because there is no net change, no net flux of CO2 from the growing biomass. But if we talk about short-term climate goals, that can have an effect on the temperature. And I think sometimes using a more dynamic approach, now if we were extending the effects of this and looking at more longer perspectives, let's say 100 years in the future, 200 years, and having this time dynamic variation gives us a better idea of how much can we expect the temperature to change as a result of an action or an intervention that we do now. While CO2 is a bit more, it's a bit more abstract. Oh, how much CO2 will we remove? But what will be the effect on the climate from the removal of this CO2? But of course, predicting the effect on the climate is itself more uncertain. But yeah, it gives a more, I think, concrete value to that number.
So if you have to choose one, which would you choose?
It's difficult to choose, I feel, because I mean, if I would, it would depend a bit on the target audience, because if you're talking about in more general field, the GPP metric is what everyone uses. It has become the standard metric. But even within the IPCC, they have this discussion that we should include a bit more time dynamic, or they have the guidelines written out for the time dynamic or more variable temperature effect as well. So I would say, if we're talking about a more general audience or people who are just setting on what is the GPP value, we need to reach this target, kind of some policy making. Then they would have a easier time, or people would have an easier time. Then you don't have to understand, oh, what is delta T? What is the temperature effect, and why does it keep changing every year? And that is perhaps more interesting for climate scientists and researchers.
Totally agree. It's interesting measurement, but I also think it's on a business side, it's hard to explain. If we're talking about, because you said we could also look at the longer time horizon, did you check or did you run the SOC model for a longer time horizon? Because I think in your slides
Yeah.
I think in the thesis it's only 50 years, but on one slide I think it was a little bit longer.
Yes, I can.
Because there I wondered, I'm not sure, perhaps I wrote it somewhere down, but there you see it's also stays a little bit stable.
Yes, it's this one. Yeah.
Yeah.
So in this one, in this picture on the right, I mean, so we assume that at 50 years we stop the cultivation, and what would happen to the stock? So there is no intervention happening anymore.
Okay, it's follow land
so,
again.
So it's or like it's basically almost like no land or like nothing is happening. It's just so what would happen to the soil carbon stock in that piece of land? And as we can see, like of course, like because this soil, this carbon that has entered, it's either in this inside or imaginary pool. It will slowly break down over time, but there is of course a delay in how it breaks down.
Yeah.
And also the inputs also have a delay. That's why like there is a small increase after the end of the 50 years, which is because of the input from the stumps that are uprooted and then added back to the soil. So they would obviously the effect of the on the temperature effect of the soil carbon, so that will extend more in the future.
Yeah.
But
and there, perhaps one last question before we go on the break. I wondered the dotted line is the live biomass, and I thought, okay, after 25 years we harvest everything and do a recultivation step. Why do we have still?
Because this picture is taken from, or it was modeled for the biomethane case, biomethane production case, because the harvest happens every third year, right?
Yeah.
So we had assumed that there are 3 consecutive plots that you can harvest, or like assume like there is a harvest happening every year. So if you would do it for only one plot of land, then these lines would also go more up and down, and when the cultivation ends, it would go back to 0, and then it can start building, which would be similar to like how we see the bars here. Yeah.
Okay. Then I would do a short break and then.
Okay, thank you very much. Then we have a break for 10 minutes. So we reconvene again 20 minutes to 11.
Yes, at least some questions are remaining, but not so much anymore. What I thought in the end and also during the presentation today, if now a politician or a farmer comes to you and says, okay, which utilization pathway should I follow, or perhaps also which farming system of the varieties of the fertilized, unfertilized variants. So what would you recommend, a farmer and also a politician who, I don't know, thinks about subsidies or?
I think from a farmer perspective, because I mean, farmers have a limited amount of land. And we had seen like if we're talking about a functional unit of per hectare, yield is definitely most important, or is the most important factor, because as a farmer, you need to get paid for what you produce, and what you produce at the present, you are getting paid for the biomass, the amount of biomass. If in the future, somehow this soil carbon effects, although soil carbon effects when it comes to biogenic or biomass-based soil carbon, because it is not permanent, or the storage time is low, it's difficult to quantify. But if these kind of effects, which can improve soil quality, effects on biodiversity, they can be somehow quantified, and farmers can get some sort of credit for them. And obviously these other effects would also play a role. But at present, I think it's more about yield. And regarding the conversion processes, that really depends on, I think, the market forces, and they keep on changing so much. Like nowadays, every year, every new crisis brings every geopolitical crisis brings a new economic crisis almost. But I would think that we need to gradually move away from viewing biomass as a fuel for pure incineration. At least, I don't know, probably more in a Swedish context, because it has a hard time matching up with the other renewables. And you had already showed in your slide that if we look at energy production in Sweden, most of it is not from fossil fuels. So there is, at least on as a heating fuel, because still, I mean, a lot of the houses here are heated using electricity and not biomass. But if we talk about hard to abate sectors, like there is a lot of discussion of greenifying the product or the manufacturing industry of Sweden. And in that case, I think producing biomethane, not just as a transport fuel, but also as a fuel that can replace, as a fuel that can be used in furnaces. That could be something I think could be very interesting from a policy perspective, because right now, I think a lot of the focus is on electrification, and usually in policy, they tend to pick one solution and try to paint everything with that one bucket, but it doesn't work that way in real life. That's why there is a boom and then there is a bust. So we need to escape this boom and bust cycle somehow and get like, we should try to do a bit of everything and see what fits what, rather than trying to fit everything into one.
Yes, we had in Germany it's the same with the biogas sector, which is also expanded and then collapsed a bit. You said that there might be the possibility to account for soil organic carbon changes, maybe in some kind of certification subsidy scheme. So my question would be, on the one side, is there already something, at least on a voluntary basis in Sweden, and how would you implement it if it would be your task?
I don't remember as of now if there is some kind of this voluntary scheme in Sweden. I had tried to look at like different articles which had looked or like were discussing about crediting this short-term storage or other services that can be provided by this perennial, mostly by perennial crops. And there is always two sides to that debate in most of the articles. Either there are people who firmly believe that because this is not permanent, we should be very careful of it and we should not touch it. Because what if you give credits and for this kind of for this certain kind of a scheme, but without then you would need a lot of quantification for it. But on the other side, it is compared to other carbon capture and storage or the carbon capture and storage methods. Growing biomass is relatively much more easier and faster to implement on a larger scale. So it does buy us more time until we can implement something that can last us longer. So I think it's very kind of pessimistic to say that we should not credit soil carbon effects or not just soil carbon, but other soil benefits or biodiversity benefits that can be achieved by changing how we grow crops and how we produce energy. But of course, the question is, how would you implement it? I think for implementing it, we need to set like some kind of different benchmarks. Like we could perhaps try to build a bigger model or but without being too detailed, which takes into account maybe different soil types. And if you have a particular soil type and if you grow a certain crop on that soil, and based on your management practices, how much credits you can get based on the expected increase or decrease in soil carbon. Because if you would take some marshland and convert it into willow or Salix cultivation, that would probably decrease the soil carbon rather than increasing it. But if you take like degraded, because we have also marginal lands and there are also degraded arable lands where like after years of cultivation, the soil carbon level had become very low. So and they are not very profitable, but if they convert it to some kind of perennial cropping systems, probably we can estimate how much soil carbon it has led to increase, or at least we can maybe even validate with some kind of simplistic field measurements. But always the question depends on because it is something which is complex or requires specificity.
Yes. You mentioned it now and also in your presentation, such simplified methods, also for conducting an LCA or CO2 footprint, to have it, because as we know, biomass systems are highly context specific. What would be your ideas to develop such simplified tools?
I think for that I would need some more knowledge, which I don't have as of now. But I mean, it really depends. I would talk to somebody who works with plant, or like you have to gather some experts to determine what is important from like what the plant, soil, and like the stand level, like what are, because we cannot look at every characteristic, because always the problem that we face when talking, like if you are a systems analyst and if you're looking at systems versus somebody who looks at, let's say, a biologist or somebody who looks at something specific, is that we look at things too vaguely, while the other side will always argue that you are missing out a lot of details because there are things happening that you don't know about. But at the same time, if we need to do calculations on large areas of land for different types of crops, for different people, for different uses, we cannot be so specific. So we need to like really choose what is important from the perspective. At now, the biggest crisis is the climate crisis. So from this point of like, if we want to reach these climate targets, what are the most important specific, most important characteristics or variables we need to look at, and really choose some of them and try to get more data on that and try to solve that problem. And of course, as like you had also mentioned before, like soil carbon was not included in most LCA studies in the past, but we see it like it's coming up in more and more, not just LCA, but other systems analysis as well. So more details will follow as we get more data as well, because all of these need to be backed by some kind of data. But we really need to choose few specific characteristics or variables that we need to put down in a system that doesn't make it so complicated that if a farmer asks a question today, like what type of cropping system do I grow, we need to get another PhD student to answer that question.
I agree. And I will perhaps send it to you later. We try to do it with also such simplified models from Scantus, where we try to do a statistical analysis to see which data points are important, which we have to measure, and where we can use generic data to, I don't know, to get down from this 35, 40 data points, we have to collect to 5. And then it's a rough estimation, but at least it's possible for farmers based on 4 to 5 data points to collect the CO2 footprint. And that was quite interesting. What I wondered also a bit, the varieties you looked at, are they the ones used in practice? Because in the end you say, okay, we have a lot of development in breeding. Are there still ones used by farmers? Or is it that you say, okay, that are the old ones and now we have the new ones and have probably to do it again?
I think approximately half of the varieties are still available from the supplier or the developer who made those varieties. While some of them are not on the market anymore because either of some problems or lack of demand or because they have developed new hybrids using this old. When this study was established, it was 2000, or the field trial was established, it was 2001. So it was quite a long time ago from now. It's almost. So it's, and since then, there have been different varieties which have developed. But because of the decrease in interest in Salix, it has also slowed down a bit, at least in Sweden. But I have seen like studies from like from Canada or from the eastern parts of the US, where there is still a bit more studies, also more field trials on Salix. And I think in the UK, they are back again to like producing local grown biomass. So there is a big biomass project going on there. And at least from one study, which looked at different varieties of Salix, but that was from Poland. And one of the varieties there was producing almost twice as much as the highest producing variety here. So definitely, I mean, the yields have increased. And when I last had met like the developer, the breeder here in Sweden, I think in the south of Sweden, they had said like, yes, the new yields now they're better and they're even more resource efficient. So of course, I mean, this character, probably the breeders have a lot of data that, I mean, they might not always want to share it, but they have probably better data on the yield and like how they respond to fertilization and non-fertilization and things like this. So,
one of the last topics I want to address is a little bit the certainty or uncertainty of your results. I had only as an example, if you're looking at the second paper of biomethane, sometimes I think it was the energy ratio, we have values between the different varieties, between, I don't know, 1.6 and 1.9 in the one variant, and in the other one, 2.4 to 2.9. And I was wondering, especially by the first one, if we have values between 1.6 and 1.9, is it really significant? So because, as we all know, we have partially really big uncertainties in LCA. So did you did some kind of uncertainty analysis? Because I would assume if we do there an uncertainty analysis in this small range, we would say, okay, it's not significant.
Yes, I think you're talking about the energy ratio, right? For the different varieties. Yes, I mean, there is not a huge difference in the energy ratio because the system which handles this is the same for all of them. I mean, there is a slight difference in the cultivation depending on how much yield it produces, because then you produce more or less biomass. We did not do a sensitivity analysis based on like this energy ratio, but I would say like this energy ratio is more certain than climate results because the energy demand is based on certain numbers and factors and like things like, which are usually more or have been traditionally studied for longer periods of time, like how much energy it takes to transport something or for field operations. The biggest uncertainty in the energy use, I would say, comes from the process simulation, because that is again based on numbers which have been done, like the conversion of the biomass to biomethane is based on numbers that we have from the lab data. And to use lab data, and if we had a pilot scale project, or at least a pilot plant, something to like do not a batch process, but more a running continuous process, that how much would be the energy required here. That's why that is something that then it could, I would suspect that it would actually improve the energy ratio than what we get from like the field data, from the lab data, because lab processes tend to be more energy intensive, or like the conversion even like kind of,
But also in the other ones, I saw you did some sensitivity analysis,
yes.
especially in the, I think it's the fourth one, also in regard to allocation method and so on. But did you do some, I don't know, Monte Carlo analysis where you look, for example, at the distribution of the data points to have more like a feeling how broad is the uncertainty range?
No, we didn't do for that. The only sensitivity analysis that we did when it comes to the biomethane case was that because we knew because the parameters for the degradation of or one of the parameters, which is called the humification coefficient, basically how fast it degrades from the young to the old pool. That was calculated analytically based on a formula that was used in another paper also published here previously. So it was like I was also briefly part of a larger study where they were trying to look at what is the effect of digestate application to soils, so that if we could like make some kind of a model out of it. But the problem that was faced, and later on I was not a part of that anymore, but the problems we faced were that how people report what is digestate application to soil is really different between different varieties. Also, what different researchers consider as long-term data, because for some 1 year of data was long-term data. Well, for some, it was like 10 years. And some studies, because if we want to specify how does digestate react when we apply it to soil, we also need to measure or take into account what are the other inputs we have to the soil. Because once that carbon enters the soil, we cannot dig it up and say this carbon came from digestate, this came from leaves, this came from something else. So it was really difficult in that to like determine this, like how does digestate react in soil. So we just varied the parameters by plus minus 20% for the digestate and looked at like what effect does it have on the net climate effect. And it was like a 10% plus minus on the changing this parameter. But this digestate effect, I mean, the digestate contains a lot of carbon because in the biomethane conversion, a lot of it does not get converted to biomethane. But how does it react or how does it stay in the soil? That is a bit more uncertain. What we can expect is that because it has already undergone one kind of biological degradation, that the biomass which is there is more resistant, and most of the carbon which ends up in the digestate is from lignin, which is more resistant to degradation. So probably that will increase, that will have a longer retention time, that it will degrade more slowly and it will stay in the soil for longer.
Yeah. One basic question which I normally wanted to ask in the beginning, you used EcoInventor?
Not for all of it. There were few data that were used in the EcoInvent inventories, but most of it was either based on like, there were some Salix specific studies done in the past. So like the data for transportation and things like this for the machinery, they were like Swedish specific field data, and there was some data which was also Salix specific. Yeah. So we used mostly that. So it wasn't a lot of EcoInvent data.
Because I know I came to this point because I wondered, you wrote that you didn't include infrastructure.
Yes.
And in most EcoInvent databases, infrastructure per se to some point integrated.
Yeah, so we did not take into account, like, let's say for the biomethane production, like what would be the infrastructure. So the building of the facility itself, it's not. So it was looking more at the process, assuming the process is up and running. So what is the effect of the biomass rather than building everything else around it?
What would you, because I thought, okay, if we look at it 50 years, even if the biogas plant is already standing, we will probably, I don't know if a fermenter lives for 50 years. What would you think? Will it make a difference if we include infrastructure?
I think it really depends on the lifetime of the infrastructure, as you said, and it's what would be the climate impact of producing those. I mean, probably in a biogas case, it would not make such a big difference compared to the total energy we would be producing. Now, if we had a specific case where we need some specific earth minerals or like very limited resources that are not available, that could have a large impact. But in this case, my gut feeling says that it should not play a big role in determining what will be the overall climate impact. And from other studies that have included infrastructure or building or like management practices, repair, and then eventual scrapping and takedown of the facility, that usually doesn't play a very big role in the overall climate or the overall impact of the facility when you're talking about longer time scales.
Yeah, I think I would also guess for biogas or biomethane, it won't make a big difference. I think it's sometimes important to include it because in some areas it makes a surprising high impact. We had some infrastructure in fruit and grape production, for example, and it was significantly high. So, but I didn't expect only the materials. But yeah, in this case, I would also expect that it doesn't make a big difference. We were talking a little bit about the interpretation, or you said what you would recommend to a politician if you want to interpret your data and give recommendations. Do you think it would change if you would do a full LCA? So you think it would change significantly the results that, I don't know, one utilization pathway would be now much better or much worse?
From the utilization pathway, I mean, obviously, I mean, the incineration part is or the heat production has the simplest pathway because there is not much added. It's if you boil it down, it's just a boiler, you put the biomass, it burns. Most of and Salix does not have a very high ash content, so the ash handling will have a lower impact on the environment. And the biogas part and the yeast oil production, I think that might have higher environmental effects because in the yeast oil production as well, we have separation of the lignin. There are certain chemicals which are used in that. There are different solvents which are used. I don't remember the exact details of the full system, but from the cultivation part, what I think might make a bigger effect on the total LCA is the freshwater usage, because if hopefully we don't grow Salix where we need to irrigate them, because Salix has a high water demand, but that's why it's more suitable for temperate climates. Like here, we would typically have higher rainfall and colder, wetter climates. But it also might have a positive impact from the ecotoxicity viewpoint, because Salix is a super accumulator. So if you grow it in contaminated lands, it tends to accumulate the contaminants within its biomass. But that would again have an effect if we are going to use it for a biological conversion process, like yeast, like depending on like if the biomass is high in heavy metals, does it affect the yeast oil? That you probably wouldn't be able to use it to produce oil that would go to human or animal feed kind of like that.
That was also so the one point saying it's not irrigated now, or I understand it. Right?
No.
Yeah.
No.
Hopefully it stays the same. We are in some or for special crops, we are changing it now. It's a bit that it doesn't survive anymore, at least in the perennial special crops such as grapes. We have to irrigate them now in the first years that they survive. And that wasn't normal, I don't know, 10, 15 years ago. And so in our region, it's already a quite significant change. With the ash, because that was also one question, you excluded the ash from your system boundaries.
Yes, we just included the transportation of the ash, but the final handling of the ash was not included in the system boundary.
What especially if you're talking about, I don't know, FIDI remendation, where we have perhaps heavy metals in the ash. What has happened now with the ash from the combustion of the Salix? Is it brought back to the field or is it disposed?
I don't think there is like, the thing is that because Salix is not used as a crop by itself in Sweden, like I didn't come across like any source like saying that how is the ash from Salix, specifically from Salix, is used. I mean, there's some ash which is returned back to like applied back to forest lands. Some probably which is then again I don't know if any of it goes to like any type of recycling, but I think a lot is still applied to some depending on the ash content, of course, can be applied to like lands.
Yeah. So I think we also model it that we applied it back because it's still, I think it contains some nutrition. There I have one question in regard to the nutrition. I wondered a bit, what substitution ratio did you apply for digestate to mineral fertilizer? Because we always said, okay, it doesn't have the fertilizer value compared to mineral fertilizer. And I think you handle it differently.
Yes, I think we took a simpler approach, basically, that we tried to calculate what is the NPK content in the digestate, and that assume that it will just replace 1:1, like the same amount of mineral NPK.
Yeah, because we all always thought like that. I think that it's available 70% or something, and then try to. You still bring out the whole amount of nutrition, but
I mean, how much will be absorbed by the plants? I think that needs to be seen. I mean, we don't know much about. Like, I think like these are also aspects of the system. Like, how does the digestate behave? Like, how much nutritional content does it actually have? Like these are some studies that we need to, if we're serious about applying the digested bag, we need to know what is in the digested and what is the effect of it.
Yeah, and I'm not sure if there's any real data available application of digestate.
Not for Salix.
And the next question would be if really biogas use is, or perennial crops are the right source, right biomass for biogas use. That would be another thing.
Yes, I mean, it's always the question, like compared to other feedstocks, like compared to like waste and stuff like compared to food waste and other like animal wastes, I would say like like lignocellulosic crops that don't have a high biomethane potential. And but I think they can be like a complementary feedstock, but I wouldn't say that somebody should build a biogas plant that runs completely on Salix, or for that matter, any kind of woody feedstock. Like in our system also, we assumed that it would be in a co-digestion facility with manure, which is more easy. We chose manure because it's more easily available here. And that something, a system like that makes more sense. But I think like biogas production in general should not be focused on one feedstock. It should rather be like we collect all the waste feedstocks that are available in a certain region, and then try to see like if we need to supplement it or add something extra to maintain the level of feedstock that's going in and to maintain the output of the plant.
Yeah, I also think that biogas plants, it should be more strongly feedstock availability based on what we have there. And I think we also calculated with perennial crops that it's only partially used, so 10-20%, either with manure or even with manure and other energy crops. I think I have one last, and then I give room to the other questions. And I think that is a kind of a standard question, but for my PhD at least, I would have to list several things. So what would you do differently in retrospect? Because if I look at my first paper, I think, oh, I wouldn't do it this way again. So
it's like, I was also like, when I was writing my thesis, I was thinking that now I know much more of how I would have done things then, but now I already have the results and can't go back and change them. Yeah, I mean, I would have changed I would have liked to have more variety specific data, because I think some of the data were a bit incomplete, or they did not include all aspects of it. And then looking like, if I had the compositional analysis and things like this from the beginning, then we could have perhaps made more choices of different conversion routes that could have been more interesting. I would have changed that, looked at maybe perhaps different conversion routes, and also if would have been possible to include some more impact categories, especially like water use and ecotoxicity and things like this, like to make it a bit more complete. But of course, I mean, then again, the question comes like, then do you have the time to look at different conversion routes, or do you have the time to look at different impact categories, and you have to choose one or the other?
Always restricted.
Yes.
Yeah. No, then thank you very much. It was very, very interesting. Thank you. Thank you for answering my questions.
I think you were very good at asking the questions.
Yeah, thank you very much. Then we leave the word to the evaluation committee. I'm eager to start.
Yeah. Can you hear me?
Yes.
Yes, because I would like to start where you ended now. Because I think it has been really interesting to read your thesis, because I think it's a very important work you have done. And one reason why it is important is that we will see or we see already quite a high increase in demand for biogas. And we will see an increase in biogas production in Sweden. And then looking at Sweden, the potential is within animal manure, but also agricultural residues and plants that don't compete with food and feed production. So it is important work, this, and I think it will be useful. But then I will go back to the question, what you would have done differently, and focusing on paper 2, because I saw that you were involved in the design for paper or the study, and how would you have more in detail designed it differently when it comes to getting data for the methane, for the biogas production and the anaerobic digestion.
For the methane production, we essentially, we had some data on these BMP values or the biomethane potential values for the different varieties. And that BMP values between the different varieties were there were some varieties which are obviously better than the others. And there was also differences between fertilized and non-fertilized varieties. Although, the range of difference was not very high. What would have been interesting, because these BMP values give us an indication of how much methane that is produced, but these BMP values are carried out basically in a container where you put the substrate and then you wait until a certain period of time to see how much methane is produced. But a real or a biogas plant doesn't work in that way. So what I was also trying to find is like, how can you predict the amount of biogas you would get in a biogas plant from these BMP values? And there are not so many studies which connect these two. So there were some recommendations assuming like they might even produce more than the BMP values suggest, and some less. So for like a conservative estimate, we assume that we get about 80% less than what the BMP values suggest. What I would like, if I had the opportunity, I would have really liked if there was like a pilot scale, at least a small biogas reactor where you could put in some Salix feedstock and see how do they behave in real time, how fast, like do look a bit more at the degradation kinetics and like how much biogas is produced over time. I think that would really supplement a study like this, because if we're trying to extrapolate lab scale data to a large imaginary biogas plant, sometimes there might be gaps that we don't know.
Yes, sure. And then looking at the details, now you used inoculum from a wastewater treatment plant for your batch.
It's not my batch, but it's the work that's done in molecular sciences
but
department.
it's still in your paper.
Yeah.
So do you see any problems with that, using an inoculum from a wastewater treatment plant for Salix degradation?
That I am not sure of, because that is completely out of my field of like how to BMP tests are run, or how do you predict which how the study of like the degradation takes place, or like this chemical characteristics. I had, when during the research for it, I had come across like different studies that use inoculum from different sources. I think one of the common sources is that you use an inoculum from an existing biogas plant and you put it in there. Now, in this one, why inoculum from a wastewater treatment plant was specifically chosen, I really don't have an answer for that.
And I was also thinking about the data you used from the animal manure. It was quite a big range. It varied between 50 to 260 milliliter of methane per gram PVS. Quite a huge range. And I was wondering why you choose the references you choose here for this data.
I remember when I was trying to find the value for the animal manure, I made a collection of like different types or different articles that had mentioned for this the BMP values for animal manure, or specifically manure from dairy cows, because we assume that these are animal manure from dairy cows and not all animal manure. So why I chose it based on like what type they were specifying, because in some papers they were just specifying it as animal manure, or like they were not specifying what type of animal it is or what type of cattle it was. But I think they had like a wider geographic range, so it was like from different countries. So it ended up being like so in some values it was on the lower end, on some papers it was on the higher end. But I classified it according to like this, tried to be as close to like dairy animal manure, dairy cow manure.
Okay, yeah, because I see you list reference 35, it's chicken manure. So
I think in the chicken manure, I think they also had like, but I didn't include the chicken manure data. I think they also in that within that article they had mentioned like animal manure from dairy cows. I think particularly in that one, I think they were comparing the chicken manure to like a dairy manure.
And in biogas production, you often talk about synergetic. Yeah, did you account for that here?
No, here we did not account for that because I think to define those synergetic effects, we would need to do would need to run some tests on it. In this one, it was like the biogas production was purely done from like a process viewpoint. So we have a process simulation. We assume that we have the feedstock coming in. We have the reactor. We set the equations in the reactor based on like how much it is getting degraded. And then we just took the values from that. But that's why I also mentioned that this is a process simulation. The process simulation needs to be backed up by some pilot scale studies or some reactor studies where we can look, because as you mentioned, like there can be, when you mix different types of feedstock, it can also have synergetic effects. One might inhibit or it might be even complementary to each other. We had looked, I think, only that the nitrogen content, the overall nitrogen content from both the feedstocks should be like a certain level, I think.
Yeah, I have a lot of questions, so I'll try not to. But just one last question, because you were saying in your presentation that the data should be easy to use, and as a breeder for Salix or biogas production, how can they know based on the data you have gotten that's okay, I should move towards this composition or structure of the Salix to get as much biogas out of it?
Yeah, if we look at the biogas, then obviously how much non-lignin composition it has, like of the hemicellulose and cellulose, that has a big role to play in that. So if we can, because the lignin adds to the recalcitrance, and also it needs more pre-treatment. And so as a breeder if you want to make Salix for biogas, I would say if you can breed Salix to have lower lignin and easier to degrade for microorganisms. Now, what thing is not captured in our study is that, as I had also mentioned before, is like if there are any inhibitory compounds which are present in Salix, which can play a big role in like if we're using it for biogas production. So the sugar composition and inhibitory compounds, those are two things that will be most important composition-wise from a breeder perspective. And I think there are some efforts which are looking into that, like also even like how the tissue structure is, the cell composition, so it does not require as much pretreatment or can be even used without pretreatment.
But I don't see the correlation between lignin and biogas production.
Yes, I mean, we did not, I did not use like or did not create a correlation between that. But I mean, it's more like if you have less lignin and more hemicellulose and cellulose, then of course the amount of available biomass for the microbes is, on paper at least, it's higher.
Thank you.
But yeah, perhaps that could be as an extra point. Like, yeah, if you have less lignin, then you have more other sugars that is available for conversion.
Thank you.
Okay, then I take. I'm not the last one. Thank you so much for a very nice presentation and a very interesting book. This is your book. Of course, I have tons of questions, but I try to be a little bit short. I'm thinking more about the experiment you used. Was it good enough? Because it influenced all your papers.
Yes, I mean, the yield and the soil carbon values, if I would say, I mean, it's good because in a way that because we did not have this kind of data before, but definitely I would say it would be better. Like, for example, especially when it comes, like we had the yield values over different times, and having 5 yield values is, I think, a good enough metric to make some kind of estimate. But for the soil carbon, if we had like more measurements of soil carbon over time, that would have been quite interesting, because now they measured soil carbon only during 2 time points. So this soil carbon data is kind of missing, which of course, I mean, it depends on what was the field trial used for, because somebody set up that field trial, and then the same field trial was used for many different studies for looking at different characteristics and different factors. Like there was some studies looking at the nitrogen concentration in the leaves and stuff. But yeah, I think like that is always the problem with, I think, field trials, because it is started at one point, and over time you realize that, okay, we can use it for this, and this, and then, but you can't go back in time and produce that data. But yes, I would like that there would have been more data. Maybe there would have been more specific data on like if the nitrogen content varies in the biomass between the different Salix varieties for fertilized, non-fertilized. That could have played a role.
Yeah, because I also got stuck in the soil carbon that I found very, very interesting. And also that the fertilized was negative for soil carbon. But what about if you would have this experiment at other sites, other soil types, and so on? How do you think that would have influenced your interpretation of fertilization and soil carbon, biomass production, difference between varieties and clones, and so on?
When it comes to the effect of fertilization and soil carbon, what I also found while trying to also look at other literature, which had also looked at this, that in many of them, they either found no effect of fertilization on the soil carbon, that they were kind of similar, or they found similar trends that when you fertilize, you get less increase in soil carbon, which kind of makes sense, because if you fertilize, there is less pressure on the plant to put out more roots to gather more nutrients, because it's more easily available. And a lot of the biomass or the net biomass production in a Salix plant is also one of the big, or is also dominated not just by the yield, which we see above ground, but also what happens below ground, because the roots in Salix plants tend to be active more or less all year round, and they have like a very high turnover rate. So they are growing and dying about 3 to 4 times every year. So, and this is also something that is very rarely captured in studies, because if you take a plant and look at it at one point in time, you see the biomass allocation at that point in time. But there are very few studies which look at the evolution of this over the whole year, because the leaves usually grow and fall once a year, the stems grow up, but usually we don't see what's happening below ground, which are the roots. And there are few studies which look at that, but not many. And most of the studies on Salix which looked at this growth and death of roots, there are a few Swedish studies, but it's mostly by a few researchers which have been in this field, and they were mostly done in the past, but haven't come across any new studies which have looked at different varieties. Do different varieties have different patterns of root growth, and how do they grow over time, and how do they die?
Now it's like we try to be above ground because it's easy. Below ground, it's not so easy to be.
And apparently, it's also very expensive to do these studies.
Yeah. But then I was thinking about this soil carbon. Well, you know, many of us here has students, and do you recommend us to do soil carbon, and how would you sort of plan a good soil carbon collecting experiment? So now you have to move into the unknown.
Also, which is made more complicated by the fact that I'm not a soil or a carbon specialist at all, which was like something new that I learned on the job, kind of. I think for soil, from most experiences of good soil carbon analysis, because there are a few soil carbon trials around the world which are like quite highly regarded, and the most important characteristics of these are that they usually run for many years, so they are very long in time. They try to maintain the same level, because if we are to measure soil carbon accurately, and we need to know how is the climate changing over these years, like the rainfall, the temperature, that is very important to measure those, and also to maintain or estimate accurately what are inputs are going into the soil and the amount of those inputs, because there are studies where they talk about soil carbon, but they don't specify with enough clarity what are the different inputs that are being put in. They might say, like, we have added digestate to an agricultural field. Okay, you have measured the digested amount, but what was the input of biomass from that agricultural field itself? So if we are to be clear about, okay, if we add this kind of substrate to the soil, this will be the effect on soil carbon. We need to be very specific about what is the type of carbon input, not just biomass input, but carbon input, and how much of it is going in.
Thank you. We talk about the plantation's effect on climate, but if you flip this around, what will be the effect of climate on the plantation and biomass production, based on your knowledge now with fertilized, non-fertilized, different varieties?
I would say, like, as the climate will become warmer, but also it depends if the climate will become wetter. If we have wet and warm climates, or the range of wet and warm climates increases, then obviously there will be more, just from the Swedish perspective, we can plant Salix even more north and get compared, because usually I think from other studies that the more north you go, because of the longer winters, the amount of yield decreases. But if you have warmer weather and more wetter weather, then probably there'll be less time the plants will be in frozen ground, the amount of yield will keep on increasing. What will be interesting is then what happens to the yield in the south of Sweden, because there will it become too warm. The good thing with Salix is that because it has a high genetic diversity within its pool, there are Salix varieties, although they look very different from each other, but because the Salix varieties that we look at for energy are the basket willows or like the shrub willows, because Salix can also be a tree or like just a bush that you don't even understand it's Salix. So there have been a few studies where they have tried like Salix cultivations in like the south of Europe, so in Spain and Greece and places like that. So probably there can be hybrid varieties which are developed, which can adapt to either a warming climate or a colder climate. But in general, I think if you talk about Swedish perspective, if it gets wetter, then probably more areas will be available for Salix cultivation, because water seems to be quite a limiting factor for obtaining good yields in Salix.
Should we fertilize?
If from a farmer perspective, as of present, yes, because we would get more yields. But if because the argument against fertilization is that we can get greater increase in soil carbon, but we cannot guarantee a greater increase in soil carbon for all field sites, but it is more certain to guarantee higher yields upon fertilization.
But what about drought? If you have a dry climate,
yeah,
then I guess what would happen then with the biomass supply?
With a that's why I would say that we should not have a biomass supply which is based on just one biomass type. The advantage with a perennial crop like Salix is that if you have one bad year in between, not just because of climate, but because maybe the market demand changes, you can let the plant stay on field, and it will delay your harvest by a year or even 2 years. Probably you would get a bit more biomass, but you can wait until the right moment to sell it. So for a farmer, it does offer some more flexibility in that way, like they can choose to either, and there are also attempts to look at green salix or salix that is just 1 year old because to use that for certain conversion processes, because it's also easier to harvest, it's smaller, and like then it's harvested every 1 to 2 years. So depending on, I think it really depends on, the climate, of course, is very unpredictable at the moment, because we have one wet year and then we have one dry year, and like how is that affecting? But I think that is also a slight advantage of our annual crops, because with the annual crop, if you have one bad year, your whole crop might fail. But with Salix, you have a bit more resilience, because if you have one bad year in between, but if the next year is not as dry, then some of that biomass will recover.
So they overcompensate for a bad year? Or...
I don't know if they overcompensate, but it's they do offer more flexibility.
So let's say I'm a forest owner, so I have some hectares, and you have many varieties, and I'm thinking of planting Salix. Will I make money? Is it a good choice for me?
Under the current situation, I think it's hard to say, because we see like for any type of cropping system, it can be even food crops. For it to succeed, there has to be a well-defined value chain that takes your product to the market, and you get some compensation for it. And you can apply that to food as well.
What is your recommendation?
My recommendation at the moment would be like, are you dependent on that hectare of land for your livelihood, or is it more like something that you can grow? It's a free or relatively freer piece of land that you can dedicate to it, and you see what happens to it, kind of like. If you would grow Salix as your main livelihood right now, according to the market structures or policies we have, I think it would be difficult for a farmer. But if you are a forest owner, which main source of income is the forest, and you have some land that you want to invest in, kind of, so that you can see what happens in the future, I think it might be good to start some Salix cultivation on it. At least, I mean, looking at the soil carbon levels, the improvement in biodiversity in soil carbon, if not a lot of biomass, you will get some benefits to your soil and local biodiversity.
I have one final question, and I have no idea what the answer. So that's why I'm asking you. Carbon credits and above and below ground carbon.
Yeah.
How will that work? Because in forest, carbon credit is a big thing. So how will that function in your Salix plantations? Can we also sell carbon credits for willow below and above ground?
Considering that the willow above ground, that carbon doesn't stay very long, and if we are going to convert it to either energy or fuel, now we are not usually making something which stays. We do not consume the wood. I would say the above ground biomass, I wouldn't consider it to be a part of carbon credit systems, because the timeline is very short. For the below ground, then again comes the question that we had also discussed before, that how do you determine how long is this carbon staying for? So in the traditional carbon market schemes, as of how it is now, it is very difficult to apply this to Salix, but it can, or this, not just Salix, but other type of perennial crops as well, because it's not only specific to Salix, it could be any kind of soil carbon sequestration. For that, we need like more data points, perhaps, or like more, not data points, but a more of measurement methods where like you can get credited, but perhaps not in advance, or not for something that you claim but doesn't exist in reality, because you can claim that there are based on one method that you apply, that this land, if I convert it from this type of cultivation to that type of cultivation, I can get 10 tons of extra CO2 removal per year. But is it actually happening? That is something that needs to be like measured, and perhaps that can be measured with like taking some soil carbon samples every year. Like, how would you audit a company? Like, how would you do a monetary audit similar to like that auditing for like maybe at least on a landscape level. Maybe it's not possible to do it for every farm.
Oh, thank you.
Okay, thanks. I'm sitting here trying to figure out what to ask and what not to ask. First, just a bit about my background. I don't know anything about agriculture. I know quite a bit about LCA, but not really agriculture in LCA. I try to stay away from that because it's so much more complex. I'm a chemical engineer, and I try to stay within the technical industrial system. It's easier to account for material and energy flows there. So I learn a lot, and I got stuck on a lot of stuff in your thesis because, yeah, it's new and different to me. But so I'll focus more on generic LCA methodological issues that I came across. My first one is about the function and the functional unit. And it's interesting. It's many years ago, I was here in a committee at SLU, and I was surprised to see that the PhD student used hectare as a functional unit. And we discussed and debated, and eventually the PhD student said, if I would have done things differently, I would not have used hectare as a functional unit. So, yeah, then now here's a paper again with hectare as a functional unit. I thought that it must be something that I'm not understanding here. And I Googled a bit for papers, and everyone is using hectare as a functional unit. So there's something that I don't understand. Can you, in LCA, the function unit, or what we analyze, should represent the function of the system, the function of a product or a service. And how can land use be a function and hectare the functional unit? Maybe it's obvious to you guys, but to me, it's not. Why do we grow Salix? What's the function of growing Salix?
Is to produce biomass that we are using to fulfill some kind of, to convert it to something else that we can use. And I agree, like in this conventional LCS system, like if you're talking about the basic definition of a functional unit, it becomes like, but the hectare is not really the function of the system. It is a feature, or it is a variable. But I think in agriculture, or because you, as you said, you Googled and you found a lot of people using hectares, because I think hectares is something that it represents a function of it represents not a function, but a land use scheme or a land use strategy. Because we have a finite amount of land that we can use. I mean, you can use the same hectare of land to produce many different things. And now we are saying that, hey, look at this 1 hectare of land. If we grow Salix on it, what it's going to, and we use this Salix for something, what is going to be the impact from it? So it becomes a kind of a comparative unit that we use to compare different cultivation systems, or different, not just cultivation, because added to the cultivation, we have the use or the conversion as well.
It's more like a boundary condition to your assessment. We have 1 hectare here where we can do different things. What's the best thing to do with this hectare? Is it always a limited? Yeah.
Limited, sorry.
A limited resource, and you will always, if you don't grow Salix, you will grow something else on it. So,
I mean, in practice, yes, land is a limited resource because we have a limited amount of available land to us with which we want to both produce. We want to produce food, we want to produce feed, we want to keep it open, we want to keep animals on it, we want to have recreation on it. So land is limited, or the type of land that you can use for specific purposes is limited. Like I can't grow Salix in the north of Sweden where it's under snow for 8 months a year. So the available types of land is limited for a specific function.
So I will have to accept for the future. But and the closest comparison I could come was to when I was a PhD student. We did LCA of waste management systems, and we had like 1 ton of municipal solid waste. And that was treated as a functional unit, but then the function was actually the service of getting rid of the waste. We can burn it, or we need to get rid of it in a decent manner. So it's not the same, but it's related. So in our case, we had a multifunctional system. We treat the waste and we recover resources. It could be heat or electricity or nutrients or whatever when we had other waste streams. So you have a multifunctional system, and then there are different ways to deal with that in an LCA. I'm asking this because when reading your papers, it was hard to wrap my head around, like, how did you organize your assessments? But with a multifunctional system, you chose one approach to deal with it, but what are different, how can you compare multifunctional systems in a fair way, other than the way that you did it?
You mean multifunction from the point of view function of the land?
If growing 1 hectare of land or farming on 1 hectare is a function of your system, that's one function, but your function is also in the paper where you grow Salix and just burn it to produce heat. That's the second function. So you have 2 functions.
Yes.
And you chose one approach to deal with that.
I would say, like, in this kind of approach, you mean like how we arrange the system, or like
how you set up your model to handle the fact that when you focused on growing 1 hectare, you dealt with the energy.
Yeah, I mean, then we calculate. Yeah, when we focused on 1 hectare from the point of view of the land, then every flow or emission, or every input and output was calculated based on this 1 hectare of land. Like how much pesticide would you need, how much fertilizer would you need, how much output it would produce, and when it is converted, how much energy would that be from this 1 hectare of land. And when we looked at from the product perspective, or this per megajoule, then it was going back to like, okay, if we need to produce 1 megajoule of energy from Salix, how much? Then it first comes the question of how much biomass do we need to produce this 1 megajoule, and then to produce this let's say an X amount of biomass to produce this 1 megajoule. What are the different inputs based on the yield per hectare? What are the different inputs to this per output or per harvest yield?
That's all the inputs to your system. But in the case where you set your analysis to growing Salix on 1 hectare, so that's equal in all of your systems, then the energy output will be different in your different systems. So that's your second function, but in order to have a fair comparison, all functions need to be equally delivered from your system.
Yes, and
you had a picture, like a rough picture in your presentation, where you use you had this substituted system, but I was never really certain how you use this substituted system. In my world, what you must have done was to subtract the avoided burdens if you produce.
Yes.
Or in each system, to sort of get rid of this second function in a way. You subtracted the burdens from this substituted system, right? That's dealt with it. Or did you?
Yes, I mean, in the substitution, we assume that the function that is fulfilled by the Salix biomass, which, for example, in the case of heat production, if that is substituting a fossil-based heat production system, then we subtract the burden of this, or the emissions of this fossil-based system, from our calculated, or this reference from this Salix system.
So So you did that for each scenario, for each variety. It produced more or less.
Yes.
You subtracted that.
Yes.
And it wasn't. I mean, I could read. You somehow write it, but you never really illustrate it super clearly.
Okay.
I mean, I understand that has to be what you do for farmer or whoever is not really used to reading LCAs, but not.
That's true.
But it's also confusing. I know that this is a common way of doing it, but I think it's really confusing to have the avoided burdens integrated with the total impact of your system, because your system is not delivering the avoided burdens.
No, it's a substitution effect.
Yes,
That's
you
what I
need
try
to
to
think backwards to understand what's
That's
going
what
on.
I tried to kind of show in this GVP graphs that I showed, that we have this substitution, but it can also be more clear, because this substitution is not a real removal of greenhouse gases from the atmosphere. It is what we would get if we're actually replacing this. But if we're just producing Salix and burning it without actually replacing something else, we don't have this substitution factor.
And it affects your results so much. And you made one choice. You chose to replace heat from fossil fuels. If you use biogas as vehicle fuel, it's more straightforward that you're replacing gasoline or diesel.
Yeah.
But when it's heat, it's very context depending, time dependent. I don't think fossil fuel is used very much for heating at all in Sweden.
Yes, I agree with that. Like if I would look back onto that is in the first paper, I would change the substitution to, because but as I learned more about the energy system, that there is really not much focus on producing heat from fossil fuels on a Swedish perspective.
Not at all.
It might be like you have some cement factory or something, or steel making. It would be like very specific cases.
Other countries, maybe. Sweden, not anymore. So to make the results more transparent, another way of doing it is to model a basket of equal benefits. Make sure that when you compare scenarios, they all produce the same amount of functional output of both of your functions. So they would all be using 1 hectare, and they would all be producing that much energy. So instead, to each scenario, you can add on the impact from producing this heat. In the end, it's the same numbers. It should be the same conclusions, but it looks differently. It's easier to see what comes from our system and what comes from the surrounding system. If we don't get heat from Salix, where does it come from? And you can also put a scenario without the Salix, no Salix at all, next to all of these Salix alternatives. So the 1 hectare of land with something else growing on it, impact that, and they produce from something else in Salix.
Yeah, I mean, right now that is what the substitution scenario is, and we subtract it. Yeah, but backwards. It's like the same thing, but the arrangement of the information. It's more like.
And I'm getting more and more in favor of not mixing the avoided burdens into the same scenario, because it's really hard to understand what's going on there.
Yeah.
So that's something that you could have changed.
Yes.
We discussed also with the opponents your choice of the reference system, how it really influences it. It's a pity that you didn't think well through what questions do I want to answer. It should be for the Swedish context. Okay, then I need to choose a representative reference system, or it should be for a future context. Maybe the fuel mix is going to change. There's so many choices one can make in LCA, and you produce one set of results, and they're very specific for exactly that case. The first thing you should do is to be super clear. I'm choosing this reference system because, and with this choice, I will be able to answer these questions, but not those questions, because then you help the reader to make informed choices. Should I believe this? Is this representative for me or not? this also relates to attributional and consequential LCA that you brought up a bit, and you're completely right that there is a constant debate between departments, between offices in the same department. And I don't think there's even scientific agreement of if I decide to do consequential LCA, how do I do consequential LCA?
Yeah.
I asked my colleague in the office next to me, how would you do it? And he wasn't really able to answer, but he was very strongly arguing for it. So where you said you had sort of a mix, can you say something? What parts of your assessment were consequential and why, and which ones were attributional? Do you think you could sort that out better if you were to do your studies again?
I would say, like, from my understanding of both attributional and consequential, that the first two studies where we looked at production of heat or biomethane, they were consequential in nature, because we assumed that we had a system or the land was fallow, and then we converted. If we would convert it to Salix versus keeping it same as fallow and fulfilling the same function of the energy with fossil fuels. If we would change the land to fallow, change the land from fallow to Salix, and we fulfill that function of the energy with the biomass that is produced as a result of this Salix cultivation. So what would be the consequence of converting of this Salix cultivation? While in the last one, it's we really don't have a defined case of like we have the land being converted from fallow to Salix, which is being then used to produce oil, but we are not assuming that this oil is a substitute. That because consequential LCS, typically from what I have seen and understood, is that you always assume that there is a change in the system, and as a result of that change, what is the effect on the environment or the climate? While here we are saying that, okay, we are producing, if we produce this product, which is this yeast oil, what is the climate effect of just this yeast oil? But we do have the land used into that, but not really that, okay, if are we changing the rapeseed oil or seed oil production with this Salix oil?
Yeah, this is so difficult. I would say some would argue that as long as you bring in the substituted system, it's a consequential LCA.
Yeah.
An attributional should be strictly allocated. If you have multiple functions,
you just divide it.
Yeah, just split it somehow based on whatever economic allocation or something. Get rid of the multiple functions, but you include the substituted system. I think the substituted system can be either attributional or consequential, depending on if you use average data or marginal data. But there the debate starts.
Yeah.
What is correct? So I think the best you can do is just be super clear. I use this because, and when I analyze my system in this way, I am able to answer these questions. And it's a little bit like floating. You may, I mean, the data is there, so you can for your own conclusions, but it is super difficult to see through exactly. And that relates to my last question about uncertainty and critical perspective of LCA. I realized in myself over the years as I teach LCA, my main goal is to educate the students to have a critical perspective of LCA. I make a living from LCA. I love LCA, but I'm so skeptical of LCA. Not because it's a bad methodology, but because so many things can vary. And the same, like starting with the same system, the same questions, they can go in different directions. You need to be super transparent.
Yes.
So if you were to present your results to a group of farmers who are interested in Salix and want to do good for the environment, and here are some results, and maybe you provide them with other people's results, what do you think they should be most critical of and scrutinize and question when they read LCA results?
I think it really depends on because specifically with biomass or agriculture based LCAs, it is so site specific and so context specific. And many times, a lot of the studies, they don't specify exactly when they assume a yield or soil carbon effects or the benefits and what the pros and cons of the system. They don't, sometimes we really miss out that which site are we talking about? And that's what I wanted to point out, that we have for example, the yield and the soil carbon effects that we have. The yield are probably more certain, that not the exact numbers, but the levels of yield or the differences between the varieties in yield and soil carbon. These variations might exist in similar situations compared to this field study. Now, if the same set of Salix varieties were grown in a different country with different amounts of rainfall, different soil characteristics, the results could have been different. So if I was presenting it to a farmer, I would like them to understand that I'm not trying to tell you which variety out of these you should choose, but more there are some benefits to Salix, and perhaps this type of presentation is not really useful from a farmer perspective yet, but more for people who are either practitioners or designing system or other, not just LCA practitioners, but systems analysts and others in general, that we need to take into account variety differences coupled with the site characteristics when we are doing some kind of impact assessment of it. Because most of the times we talk about a certain crop, but we forget that for each crop there are many different varieties, and this can have a role or sometimes have a very significant role in how not just the climate impact, but the overall effect is on the biosphere.
So the farmers would just try to say, okay, these scientists, they don't never tell us anything. I think the best way to use LCA is you can develop some sort of rules of thumb that you can communicate. Not explaining the results, but rules of thumb for sort of robust decision making. Don't do an LCA every time.
No.
You can't afford it, and it's Okay, thank you.
Thank you very much. And we have the reserve. Do you have any questions that you would like to add?
Hi. Now here comes the questions from me. And I'm putting it in the context of a systems analyst now. I do a lot of LCAs, but also energy analysis, stakeholder engagements, and so on. I have three main questions, basically. It comes down to uncertainty and robustness, recommendations provided, and relating to creating systems out of a mix of scale-up and laboratory results. So regarding the uncertainty and robustness, my question to you is, so after reading thesis several times, I couldn't find information regarding how are you handling unexpected events within your system. So for example, culture crashes, some things that's going wrong, because ultimately this will affect the environmental burdens of the system. Because there has to be someone, you just don't, if the system fails, you just don't stop there. Usually you do something and you restart or whatever, but this ultimately adds up to the burdens. So that's my first question on the robustness. My second question on robustness is regarding for example, in our case, we were working in Africa. When we have a technical system, yes, in a way you have modeled it, so that the function is related directly to the system. But in reality, the practitioner, let's say the operator, let's say he's taking a bus to the farm, right? He's not just doing that for Salix. He's also doing other things. So let's say if he's distributing fertilizer, but the input flow is actually a combined, because he's not doing just for the Salix farm, he's also doing for other farms in one go. How did you differentiate these non-technical inputs, as I usually call it? So that's the first question. And then the second question is, when it comes to making recommendations, I know that your target audience was more sciencey, but in reality, most of the people who create systems are actual farmers, and they are the ones that will take on this work, and they will say, okay, in the future, if they were to design a system, what should the take-home messages be? But I think in some ways, I feel like the function that you provided, I'm not so sure how would that be translated to the person receiving your target audience, basically. And my last question is more about, what is your highest uncertainty based on, because you're using lab numbers and operational parameters. So for example, when I did biogas, I remember that there was a technical report in Sweden, where they say that a lot of times when they scale up the biogas system, they will only manage to, the worst case I'm talking now, not the best case. The best case, of course, they could get more biogas and whatever, but the worst case, they only achieve 30% of the yield that they found on experiment. If this was the case in your system, would the conclusions be totally changed? That's all my questions.
Because you asked them all at the same time, it's difficult to remember. I can start with the last one. That's the most freshest, that if the biogas conversion is very low, if in this system where we are applying, if we have low biogas conversion from the feedstock, what would happen is that a lot of the carbon would end up in the digestate. So you would have a low energy output, but possibly still theoretically based on the model, because your soil carbon, your input to the soil in terms of carbon would increase. If we assume that the same rate of application as we have now, obviously if we would change the rate of application, then it would be different. But yeah, then the amount of carbon going into the soils from the application of digestate would change, which would possibly lead to a greater soil carbon sequestration effect, leading to a greater effect on or negative climate impact. But in terms of, then it depends, like the output of the system in terms of product, that would obviously decrease, then you would get very less biogas. Then using Salix for biogas would more be like you are using it to get some biogas, almost like as a benefit, but your main purpose, what is the main purpose of the system? Is it to just add carbon to the soil? Then it would become, the soil carbon addition would become the main function of the system. But yeah, and I also had this same issue, or like same question, that we have this lab scale BMP values, but they're lab scale. How much do we actually get in a reactor? And many studies do just assume, take the BMP values and use that to calculate how much methane is produced. I only found a few studies which they tried to compare lab. They had a lab study, like, oh, this is the BMP value in the lab, and how much methane are we actually getting it in a pilot scale reactor? And then that it was around, like, I think somewhere it was like 70% to 90%. So I tried to look at some and made an estimated assumption that we'll get like around 80%. But obviously, I mean, to get better numbers, we need a pilot scale project. And then you had a question about the uncertainty. Can you repeat it again, please?
Like the robustness of your system.
Yeah.
Yeah. So, for example, I look at systems that are mostly dealing with invasive species. That's my main work. So, for example, when we were altering biomass.
Mm.
They are susceptible to crashes, whether it's human error, whether it's a contamination, whether it's a virus or something. And then when it crashes, you actually reset. And resetting by would be, I mean, if your system is in a matter of days, then it will take several weeks to decontaminate. If it's, let's say, an orchard, you would have to corner a certain area, corner out and remove.
It's like if you have a bird flu outbreak and you have to kill all the chickens.
Yeah. So basically, how do you factor in this? There needs to be like if you were to say, okay, this system has this impact, then if something happened, oh, this number doesn't work anymore. So it's more a question of the robustness of your result. Have you investigated this aspect? I know a lot of LCs doesn't.
Yeah.
Out of curiosity.
Like I haven't come across something like that, but of course, I mean, you're talking about factoring in this both human factors and also like natural catastrophes or like some kind of what if scenarios, like what if something goes wrong, terribly wrong.
So what I did in the past was rather than doing a what if, I just did like what you did, but then I added a one column, and then I basically say, okay, based on let's give it a sign probability based on the risk. Let's say if you have a culture of 365 days, but 2 days of every year there's this problem, and this one event lead to a 2-week cleanup, for example. So how would this affect? And then I just run 5,000 trials basically, and then I say, okay, what is the
what is the range basically you end up with?
Because it's like for me, it comes down to like, okay, let's say you say that this is the result, but is it actually that? Is it or is it one of the interval? That's my.
I haven't done something like that, but if I was to do, then I would like choose one of the conversion pathways and then look at like then that would represent a more like real life scenarios or multiple scenarios. What you're talking about, I think, is like that you would end up with a range of scenarios and you will end up, your values might end up, let's say you will have a most probable range and a more positive, like highly optimistic and a highly pessimistic value. I haven't done something like that, but yes, I mean, if I would choose to include something like that, then I would probably not be able to do for all the different varieties, or not, at least for not all the different conversion routes. Then I have to be more specific to one route, define what are the different, it's like as you explained, like different events that could take place. Like I think one event could be like, as we said before, also like what you have droughts. Suddenly, like there is a drought for 3 years or 4 years, how would that affect? So we could define some events and yeah, that would be interesting to include. Sounds like a lot of work, but seems interesting.
It is what it is. But my search is more related to that because basically to a farmer, who's going to be the one who design the system? And since you were saying that you got a target audience is a systems, one who create a system, that would be the farmer ultimately. And when the farmer does this, they can either do it for usually from what I know, the 3 reasons. One is that they have some kind of waste they need to get rid of. 2 is that they have, and that includes free land. And 2 is that they're interested in the, let's say they want to, and they want a pathway to do this with extra money. And the 3rd way is the main product that you suggest. In order to the system look at multiple functions, but at the same time to address this to our farmers, to the farmers' needs, or the person who made the system. Because that's from what I'm reading about the thesis, that seems to be the target person, the one that created the system, but still not able to connect how the function, the system we define is going to be reflected to the function to which your target audience is considering. Do you see what I'm saying?
Yes.
So how do you, because you have several take-home messages at the scientific level. I'm just curious,
but
how do you translate that to this?
To a more like farmer.
That's your target of the analysis. And I don't see how the results are going to be reflected in a one-to-one manner. You see what I mean? I give you an example. Let's say you do an energy ratio, and you have a main energy product, and you have digest state. But how do you factor in the digest state into it?
The digest state is not factored in the
exactly.
energy ratio.
Exactly.
Yes, because
but to a farmer, they would consider.
Yeah, I mean, there is a benefit of the digestate, which is not captured. Like, I think that comes down, doesn't it come down to like what we are using to compare or describe the effects or describe a system. Like if we use energy ratio, we don't get into, then it works purely on terms of energy. It doesn't discriminate between types of energy. I mean, a typical energy ratio is just energy out by energy in. But how much of that energy is fossil-based, non-fossil-based, renewable, non-renewable? How much is the cost of the energy? That's also doesn't come to. I think that would always be kind of like a drawback. But if I would talk about my work, then or the approach, I would say my intention was to show that through the work that these variety differences play a role. But if now from a farmer level, how do they include this information in their system design or system? Then I would say, like, from a farmer's perspective, their most important resource is their land. And from a land perspective, from a per hectare perspective, the yield level was the strongest had the strongest impact on the climate impacts. But then the question comes, is the farmer concerned about climate impacts, or is he concerned, like, how much does that role play in this? But at least with the yield, you have, I mean, usually you get paid for the product you produce. In this case, it would be the biomass, so they would get some kind of economic benefit from the yield. So I think then they would focus more on the yield, which is kind of like the typical approach anyhow, like for most people. That's why I think, but this is not a complete picture, I would say, because we are not looking only at climate impact. What about other secondary effects, especially when talk about biological systems? It has a lot of effect on the local ecosystems, and not just ecosystems, but also social structures and social, like, incorporating this kind of results into a larger scheme is very important. Like, I would not say that you should take decisions based on climate impact results only.
Which leads to my last question.
Yeah.
So based on that, what would you recommend stakeholders or the farmers, systems analysts, to use your results? What needs to be complemented? So for example, take economy analysis or whatever.
Yeah.
What would be your recommendation in terms of, like, okay, you can take this information, but you need to do the additional.
Yeah, it's like
like
you are building a thing with blocks. This is one of the blocks, which is like we're looking only at climate impact. I think what is also very important from a stakeholder perspective of the farmers and such is the economic aspect as well. And then from like the local regional aspect, you have the effects on biodiversity, and also what are the social, because most of these biomass sources or bioeconomic sources, they say that this will lead to creation of jobs at the local level instead of using imported fossil fuels that's coming and going into a factory and things like this. But how much of this does actually play a role in the regional social structures and social hierarchies? Because suddenly somebody who can become a producer of not food, but some kind of biomass feedstock. So it's almost like you're changing a farmer to an industrialist, kind of, in a way. So how do these factors play into it? So I think there's so many things you could add to it. But at the basic level, I think at least we need some kind of economic analysis, including and also expanding upon the climate impact, including effects on the environment in general, and if there are any complementary effects with the local systems, or there could be some derogatory effects as well. Maybe the Salix is competing with another energy feedstock which is already there, and you try to implement it, it doesn't work, because obviously there is something which is already cheaper or better suited to that climate.
Good. Thank you. Then we're open for the remaining audience. Any questions? No, it's very quiet. Yeah. So thank you. And I would like to thanks for the very nice discussions and questions. It's been really interesting to listen to. Also the presentations were really suited. And if I should summarize what I have heard today is it's been quite a lot of discussions on methods, and sort of the importance of input data is something to really have in mind. And also the functional unit is very important to actually decide what it is and know why you have chosen your functional unit. And then it's been also discussions about why it's only 20 centimeters of the soil important. Why isn't it more? And why is it only a 50-year perspective? As it's normally much more or shorter. And then it's a bit of, for me also as a chemist, I think the carbon quality was quite interesting to listen to. Why is sort of the soil carbon quality, and we have also the discussion about the Salix carbon quality, what it can be used for, and what happens then. And then we have moved into trade-offs and looking into sort of conflict of interests, and heard about the sort of the importance of this research that have been performed, because it's an area where we have agriculture is quite a big contributor to the planetary boundaries. At the same time, this research is actually contributing to decrease sort of the planetary impact of agriculture. And that we have to have in mind that it's not only that we have to sort of be carbon neutral, we actually have to be carbon negative in the future to actually reach sort of the climate goals. But the quote of the day that I bring with me after today is actually what you said after your presentation was, grow Salix and save the planet. But so with this, I close this session and thank you with a big hand.